Okay, so how would we like to begin? Maybe a question for Mr. Keshe, or do you have anything in particular you'd like to start with, Mr. Keshe? Anything you'd like to announce or say before we launch into questions?
Not really.
Okay.
As we come, it will done.
Right. Okay. Does anyone have a burning question they'd like to start off with here too?
So my question was, with both patents, you refer to Mr. Randall Mills and his work with bringing the electron below ground level state with a catalyst. And I see a lot of similarities in terms of what he has found with that technology of his compared to the patents as well. As in the stages of turbulence and EUV and magnetic field as the proton is emitting more gravitational and magnetic fields when the electron is below the ground level state.
Can you repeat the name? Is this in our patent?
Yes, it is, with Mr. Randall Mills and his theories of the hydrino and blacklight power.
It's a company called Blacklight Power, and it was mentioned in one of the patents as a reference.
This is something which the patent writers have put in.
Okay.
Yeah.
It's not something that you ascribe to or have.
No. This is something most probably the patent writers have added into it.
So a plasma, like a plasma in terms of my definition, would be a atom with the electron below ground level state, which is all the way from ground level state all the way into the proton, which would become the initial fundamental plasma. Is that correct?
Can you explain what you call a ground state?
Ground level state is the state in which science today tells us the electron can no longer go further down due to the Coulomb barrier. And with a certain catalyst.
The electron can literally even re-enter the proton.
Right, due to the catalyst of removing that Coulomb barrier.
This is totally something which we know. If you change the gravitational magnetic field of the electron, which can be done, we call it interatomic fusion. So you can bring the gravitational magnetic field of the electron in balance or equal to the electromagnetic gravitational field of, what do you call it, magnetic field of the proton, by releasing it, by releasing more of the, what we call the principal matter. And this, in one of the papers I've written, we call it interatomic fusion, which is a more practical way of creating fusion. So zero state level is meaningless. As much as a neutron divides into a proton and electron, you can create a condition where electron can be re-entered into back to proton. You won't get the same level, neutron level, because you lost some energies at the beginning of the division. But there is nothing called the zero level or ground level energy, that the electron cannot go any further. This is the old theory. Now we understand the principle, this is meaningless.
So the basically further, the electron is closer to, sorry.
The electron can be at any closer or further from a proton. The position of the electron, or what I call the range with the electron, can move close to and further from the proton. It entirely depends on the amount of the principal matter which was left in electron and proton at the point of the division. So depending on all the material which is left at the division, at the time of the division, decides the what do you call it, the bandwidth of the motion of the electron. And all electrons don't have the same bandwidth, and all the protons don't create the same gravitational magnetic field strength. So there is a spectrum. There is not the physicality of the restriction on exact amount. In one of the papers I've written, I have, I think it's even in book 3 or book 2, somewhere I refer to that atomic structure in this, what we call universe, creates the bandwidth of the electron in respect to proton. In different environments of different gravitational magnetic field, this bandwidth could be totally different. So what the proton creates as a maggrav and what the electron creates as maggrav according to what they receive at the time of division as a source dictates this bandwidth. So principally what we've seen with GAN's state of matter, you can dictate this bandwidth, and in what we call interatomic fusion. Interatomic fusion is much easier than the present fusion technology they are trying to do, where the electron itself is within the Coulomb barrier of the atom, where when you try to do fusion, or what they call the hot or cold fusion, you have to cross a stronger barrier. So this is an old technology. Pardon?
You can remove the barrier with different environments, as in different elements, correct?
Yes. We've seen this. We've seen this in some tests. We see it not physically. We see changes which we don't expect, and we understand it could be the what do you call it? The background to the electron remerging into the proton. The energy release is minute but is effective. So in a way, if you consider like get a glass of water and warm it up and put a sugar block in it, in a right cold environment, the block stays as a block. As you warm it up, you create an environment that the sugar dilutes and mixes in the water and you don't see it. So you have, if you create the same kind of magnetic gravitational strength of the atom in your reactor, the plasma of the electron will mix with the plasma of a proton. So is creating the environment of.
But would that be the definition of a plasma?
Then you have a new plasma. Then you have a new neutron.
Right.
Pardon?
Which is stronger than if the electron was in the outer shell instead of melded with the proton.
It was what? I missed it.
A stronger emission of rays.
Not necessarily. Not necessarily. What happens is that we consider that the principal matter of electron will join, or because it's of the same source, will rejoin the principal matter of the proton, which is a larger mass or bigger amount. So you should not see such a big difference. It's exactly like what you observe as a neutron. So the plasma of the new neutron from the re-emergence or fusion of the electron to proton should be more or less just under a normal neutron. So you create a condition, you create an environment for that the plasma of the new entity is the same as a neutron, where electron merges. I've called this interatomic fusion, This is a more appropriate way to create energy or release energy, because you can bring the electron closer or further from the proton as you need or as you want, according to the environment you create for that position to be dictated. We see this in galaxies quite regularly. We see this in emergence and division of stars in galaxies, and the same with galaxies in the universe. So it's just a parallel. If you look at it in a given time, the book number 4, which is coming out, is written. Hopefully we can get it out soon. This we explain that, for example, the position of the Earth in respect to the Sun is not what we see. Earth in due time will lose some of its gravitational magnetic field strength, and it will go back and rejoin the Sun, where it came from originally. So as the gravitational magnetic field of the Earth changes, reduces, or becomes in a way irrelevant to the magnetic gravitational field of the Sun, it will get what we call fused back in. It's a natural fusion process, and I'll explain this in the book clearly how it happens. So there cannot be any difference in the atomic structure as well.
Okay, so that is the way that nature works then, by creating the neutron, well, a different type of neutron through that kind of a process.
Yes, but neutron itself, we call it a neutron, it's a plasma.
Right.
It's a plasma which itself, somewhere down the line, was created from a division. The term neutron has to be redefined as a balanced maggrav, or I call it as a gap in in the book number 1 or 2, we call it as a gap. It's a spacing which allows different plasma of protons to find their distance in the structure of molecular or atomic structure. Then when that gap, or one of the electrons or the protons moves, which forces a division, neutron, due to its change of environment, changes its maggrav, and it divides into electron and proton. The process is very clear now, that how what do you call it, a neutron tends or happens to be in the center of atomic structure.
So that's why.
Pardon?
Sorry, that's why bringing different elements into matter is just a matter of making the correct gap. Is that right?
That's all it is, because you it's not creating the gap. The gap is created because of the forces of the protons, and in that gap allows a neutron to have a space to accommodate itself as a balancing between the two, because neutron has its own maggrav, and in conjunction with the protons, this decides the position of it. Some of the things which we see in nuclear fission is when the atom divides, how electrons, protons, and neutrons take position in a new division. And then you see that neutron is literally, with a small amount, is the same as a proton. But the
neutron supposedly
balancer, it plays a gapper in the process.
Right, because the neutron's a dipole, so it's holding in protons and able to expel the electron as well. Is that right?
This terminology has no meaning for me. So the way I look at it is it's a balancer. It's something which is there to create a balance between the protons, or the protons' magnetic gravitational field create a position for neutron to be there. And then in turn, because neutron itself, it creates its own maggrav, when the protons or one of the electrons moves from outside rings or for whatever reasons merges with another one, what do you call it, with another atom, or shares, it forces it changes the position of the protons internally, and that change forces if a neutron is going to release or divide into two parts of electron and proton. With universal, what do you call it, phenomena in galaxies. This is what I call very much down to the basics of the nuclear physics, and understanding that even you call neutron neutral, if you remove a neutron, you'll find the atomic structure will not have the same property. That's why we have the isotopes in different shape and forms. So neutron still dictates, has its own gravitational magnetic field, but it needs to be there as a stopgap or a gap, to be there as a backup, because neutron itself within the structure of the central process of protons releases a lot of energy into the system. It's another plasma. It releases its center, which is its principal matter, constantly releases energy or magnetic gravitational field into the atomic structure. It's not there, it's not bipole. Iridium bipoleness is meaningless because it's a plasma, is active, and by the same measure, it behaves like a star. Its gravitational magnetic field has a direct effect. Pardon?
We're just really seeing the outer shell when we look at a neutron.
I can't get it, you keep on getting cut off.
Sorry, so basically when we're talking about a neutron, we're still talking about matter. So
yes,
we're basically still just seeing the outer shell and the matter form of the neutron.
Yes, but that what we see as out is just what I call the outer atmosphere. It's like an upper atmosphere of the Earth. Is what we see as neutron is the point of its interaction with the magnetic gravitational field of the plasma of other protons or proton in that structure, in the central structure. It cannot be something neutral. This neutrality or bipolarity is meaningless, because this entity in due course, when the environment changes within the structure of the atom, it divides itself to a proton and electron, or is forced to find its balance, that it releases some of its plasma to keep the balance of the atomic structure, and that released plasma becomes an electron. This is to rewrite all these physics books. A lot of principles has been accepted, which has no true ground in the physics. Neutron is not, it cannot be bipolar. It's just something written to explain what they cannot understand. It's like saying that the sun has no power in the solar system. These neutrons are effective, powerful sources, which are part of the structure, but they are accommodated in the, or they find their position in stopgap. Something which is fundamental, and I try to keep on remembering to write in one of the books, and I forget, is that a proton or electron or a neutron, these are packages which the magnetic gravitational field of this universe allows for a package to exist. So the package of plasma of a proton or an electron or a neutron is what is dictated by the central gravitational field force in the center of the universe. It's not just random. Is part of the totality that this amount of principal matter, which can release so much, behaves this way. So it cannot be any different. Neutron is on its own, and it plays a role in the electron. It cannot be on its own doing nothing. As I said, you say the star in the solar system does nothing. It's meaningless.
So is it just the quantity of the, as you said before, it's the quantity and the entity?
Yes.
So when we talk about the neutron, can you have multiple neutrons without protons or electrons?
It can be done. It can be done. In some of the structures, nuclear structures, when you look, protons don't sit all in one in a given position. They find even gap or distance without any electron in respect to each other, because the totality of the balance of the plasma of what do you call it, central core, which counts. So how can they be in that position if they don't have, or they don't release both the gravitational magnetic field? A neutron is an active part of atomic structure, opposite to what is being taught at the moment in the textbooks. It is a very, what do you call it, active part, and it has a direct involvement in isotopes. If the physicists start looking into the magnetic gravitational field of the neutron, they will find out a lot of mysteries which is sitting within the structure of isotopes. The isotopes are mainly dictated by the positioning of the neutrons more than anything else.
So you could take another neutron and add it to an atom and create a different isotope, right?
Of course, we know that this is a known fact. This is what is there. Well, the thing is, the magnetic gravitational field of the atom itself dictates for its balancing if it's extracting or absorbing a neutron or rejecting one.
So you'd be changing
because it
the
has to
element.
have this balance. It has to have gravitational. Yes, it's both ways. It's not just absorbing. As we know, neutrons are released when it's not needed. This is one of the biggest problem which Keshe Foundation has in military. As you know, we produce a lot of plasmas in different quantities as we need, especially when we used to use nuclear material. So in matter of few cents, you can create a nitrogen bomb, neutron bombs, and you can create oxygen bombs. Once you understand the concept, the neutron bombs and the hydrogen bombs become meaningless, because the next level is more powerful, because you can release a large number of energies of bigger atoms. The structure of atom can be changed without creating any heat or creating any what do you call it, disturbances in the environment, if you use interatomic fusion. As much as you can bring an electron to be absorbed by the proton, within the center of the core of an atom, you can facilitate the protons to rejoin a neutron. This releases huge amount of energy. This uses energies which mankind cannot have the comprehension of, because the energy within the central principal matter of a neutron and a proton if used or you create the right environment, can be released in one go. This is what I keep on repeating in some of my talks, and it's getting missed and it's not understood fully. Let's take an atom of hydrogen. The principal matter, the principle in the proton, the principal magnetic field in the proton, in the center of proton, has been there for billions of years. And it's going to be there for billions of years. So the tangibility and the visibility of the plasma of hydrogen, proton, is there for billions of years. So the source is continuously releasing. And a source which can release enough energy to be visible or detectable for billions of years must be massive. This is what physicists don't understand. And they keep on talking about these upper quarks or down quarks and whatever rubbish they came up with. The center of a plasma of a proton, there is such a vast amount of gravitational magnetic field or principal matter in a compact form sits that can guarantee a continuous life for that plasma for billions of years in the environment of an atom. So you release that in one instance, then you know what sits inside. That's one of the reasons governments are pushing to bring Keshe Foundation down, because we have opened what they thought cannot be known by man, but we use it for peaceful purposes.
Right, we don't have to think about the war aspect of it. There's the other side of everything where if you don't include war, it can still solve all our problems.
Yes, but you have to go a step further. Even the energy within the center of the plasma of the electron, which that electron uses more energy than the proton itself, is much more than the proton. This is another concept which is misunderstood. If you look at the electron, which is moving so rapidly around the proton, it has an energy. Can you hear me?
Yeah, I can hear you.
Yeah.
Yes.
If you consider the energy or the magnetic gravitational field, amount of gravitational magnetic field are released by electron to be in motion for billions of years around the proton, then you understand even the electron, principal matter, due to its compactness, can be much more than the principal matter within the plasma of a proton. Partially, the principal matter dictates the bandwidth of the electron in respect to proton. But that bandwidth to be kept, there is a need for a continuous release of gravitational magnetic field from the electron. So you release this amount of energy of the electron, which sits in its principal matter, in one go. You release billions of years of motion, energy for motion. So this is what is getting missed in the world of physics. We just look at something, we say, oh, there is an electron. As I said in my lectures, some people have been. I put a bottle of water on the table, and I put 2 glasses. And I empty the bottle into 2 glasses in 2 different measures and said, this is a proton, this is an electron. But in reality, there is more in electron, but it's a more compact environment. Is more squeezed to hold. So one of the questions which is fundamental to ask and answer is, maybe the energy which is contained within the electron is much more than what we think and is than a proton itself, even the dimension is smaller. The present nuclear industry doesn't answer this. Pardon?
because physical dimension really means nothing in terms of a principal plasma. Is that right?
No, nothing. Yeah, it's just like a black hole. The size of it in the center, or what we call a principal hole, principal star, is irrelevant to what is released, and it controls the whole galaxy and the universe. So, in a way, I always consider that electron holds much more principal matter, stronger principal matter in the center. So both of them, even if you look at the structure of the plasma of a proton, this entity is there for billions of years, and for something to be there as a plasma, to show itself, to create gravity and magnetic field that it creates, is what I call as atmosphere, that we can physically see it or detect it. Then you can imagine how much energy is sitting in that center. Billions of years, and now you consider the motion of a small bandwidth of electron in respect to proton, and you call it electric current, and we use it, or we say millions of it gives us whatever, joules or so many kilowatts or whatever. Now open that energy in the plasma, then you see the mystery of the universe. It is enough energy in a proton or in an electron to give a man's life energy what is needed in a lifetime. You release billions of years. That motion doesn't happen on its own. We got habitually into the state because we don't understand this. Oh, electron moves around the proton. But that electron moving around proton needs gravitational magnetic field continuously to be released, that position is kept. Where does it come from? Both from the electron and both from, and this positioning is kept for billions of years. Now people have to start understanding how much energy sits, how much gravitational magnetic field sits within the structure of the electron. Is enough energy to whatever you need to use and eat for the rest of your life. Maybe generations, but we never looked into it. We looked at it because it's so small. It's so small, but it's there for billions of years. Measure how much energy is released by a proton and electron over billions of years, and then imagine how much you need to live. Then you understand we've been looking at the wrong direction in the world of science.
Okay, thank you for your answer. I really appreciate that. It was really informative.
Thank you, Mr. Keshe.
Could we understand the size of the electron as being very small because of the quantity of principal matter there is in the electron?
Quite possible. Certainly, yes.
And because the principal matter doesn't interfere directly, it's there, and it doesn't appear to us just because it is a principal matter with high level of energy.
Yeah, go back into what I put on the forum a few days ago. Define the energy, then you understand how. Energy is gravitational magnetic field in motion, magravs in motion, because it's got to be both of them for it to be an entity. So one of the principal things which I keep on re-emphasizing in the book and in my talks is stop thinking as a magnetic field. Think of the magnetic gravitational field is 2. So the energy, if it's compacted, if it's much more stronger, it has to be, what do you call it, smaller. Remember one point, the size of the plasma of a galaxy, the solar system, a planet, is not dictated mainly by the entity itself. It's dictated by the magnetic gravitational field of the environment which that entity operates in. This is very much like you have a room full of balloons, and you try to get another balloon inside the room. So the other balloons inside dictate what size this balloon can be. If it's too big, it can't come in. If it's small enough between the balloons, you can accommodate it. So why proton has such a large dimension in comparison to the electron? Because, or does it get dictated by the energy of the electron itself? Electron has a very direct control over the size of the proton, not the other way around.
Yes, and the mass of the proton towards the mass of the electron seems to be in the favor of the proton. But even though the quantity of principal matter in the electron is greater. So it's only the matter part.
Yes, but there is a measure of the principal matter, the electron. The amount of the principal matter inside the electron, which dictates the mass. It could be much more compact, but the mass is the balance between the what we call magnetic field and gravitational field. I'll explain that in the book number 1. So if you put that together, there is a high chance, I try to find a parallel. If you look at the solar system and look at the Saturn and Jupiter, they are huge, but their size is dictated by their position in respect to the sun. As over time they lose, or the gravitational magnetic field of the sun pulls them to themselves, they get stripped of the gases around them, and they become the size of Earth as they reach the position. This is what I call a rainfall system, exactly like as the magnetic gravitational field of the sun release themselves. As they lose their strength in the boundary of the plasma, they rain back in, and they become part of the outer, planetary system, and that's why they're so big. But in fact, the gravitational magnetic field in center has been decided by the solid material inside it, which initially was like a Pluto. So internal mass decides what material is absorbed and what gravitational magnetic field and what size of the plasma of the planet will be in that position. The same thing happens with the electron and proton. We see similar structures in the universe in respect to suns and the galaxies in the galactical system and in the universal system. We don't see, and what we see from the data which is coming from new planetary systems which are found in the galaxies, the position of the solar planetary system is dictated. You see more of them the further you are from the center. And then these stars, which gather a strength, or they are much more compact, or they have a higher gravitational magnetic field of the principal matter, they tend to be closer to the center of the galaxy. And planetary systems are always on the wings, not in the center. The same thing, the same principle applies.
Okay.
So, Mr. Keshe, would you say there's likely not much in the way of life as we know it in the inner planets of the galaxy? inner arms, rather, of the galaxy?
Life can exist in any shape or form anywhere, even in the center of the dark principal matters of the galaxies. Life has no limitation, depends what you want to call life. We look at life or existence is, to me, in what, even as a single plasma, can dictate its position and its motion and its interaction with other things. So I was actually writing a paper which is going to be released hopefully very soon in the next few weeks, that is called The Origin of the Creation on Earth, how the first life ever started on this planet. I explain how, and even how muscles and tissues and motion of muscles and tissues were started on this planet. Because now we have created an environment very similar to the start of the creation of life on Earth in laboratory condition. I showed it to our guys in the Keshe Foundation team working with us a few weeks ago. This has been going on for about 2 years now. The process is ongoing for 2 years. Then you understand that life, or what I call repeating and holding and reacting to environment, what we call life, it can be in the center of a principal matter, in the center of what we call a black hole. Because in that condition, in that strength, the matter or the entity has found a way to move. This myth of life being exclusivity of certain planets is out of the window. In fact, I'm pretty sure very soon, very soon, shorter than most of people can think, we can confirm existence of intelligence or life, whatever you call it, in the center of the stars, or in the stars, or on the surface of the stars. Because that environment allows the creation or existence of certain materials which can, or certain plasmas which can operate and function in that environment. This is what we said, life cannot exist at the bottom of the seas, and life cannot exist at other positions. Understanding the state of GANs, it puts this through the window, is finished. Life is not exclusivity. Life as something who interacts with his environment and can respond to his environment in his position, and maybe dictate the position, his own position, his own environment. It can exist anywhere in the universe, even between the planetary system, in the open spaces of what they call galaxies and others, because that environment allows this. And we've seen this in the new detailed videos from satellites by NASA and other organizations. Life is not what we call is exclusive. In this universe, there are entities, single or multiple, or as an organic like us, or as organs, not organic as like us, exist in that environment because they can use it for their own existence. This exclusivity of intelligence and us being the superior entity is we are at the bottom of the pit in so many ways.
Yeah. Okay.
It's hard to understand, but this is a fact.
No, so what you're saying is that life exists in all environments, which we've already proven on Earth that's true.
In all environments. In all environments. Even life exists in principal matter level.
Right, just because we can't see it doesn't mean it's not there.
Yes, because we had somebody posted a video recently on the forums a few months ago with the things moving in the satellite, and they're saying, what is this? These are aliens. No, these are entities which can exist in that position. we have passed the barrier of what's in the book. We have to believe. The reality is what is in the environment, what is in the universe. We have to accept.
So the environment is
couple of weeks ago.
Sorry.
I don't. That is, I'm not a believer in what people call about UFOs and other things, because to me, it's a reality. We were standing, and we were not the only observers, where we could see motion of what we call a bright light in the sky, because it was very clear. We were on a lake, and there were 3 aircrafts flying at the same time, in the same horizon, the same distance. So we could clearly see the difference. What do you call this? Where does this intelligence come from? And the movement is very much like, it's a very strange way. It's exactly what we call a bright light in the sky. But the motion is in the background. Pardon?
I believe that will come from Italy, won't it? Won't it have a made in Italy sticker on it?
Pardon?
I was just trying to make a joke, but you were saying that the first craft launched from Italy, so I said it might have a made in Italy sticker on it.
No, that's already the Iranian flag on it. That's without a doubt. That is the gift which the Iranians will give to the world. There is a discussion, there is a radar problem, there is a lot of talks in the background in military and in other bits regarding the situation with what they call UFOs and the Iranian spaceship program. And we are getting tagged for it as all sorts of things. And my message to the people who do these things is put these things down. At the moment, more and more nations are getting access to this technology. So we've got to use it the right way instead of using it as a division. We came here to look at our Dutch and Belgium system. Are we going to see this?
Are you ready to show something there, Geert?
Yeah.
Okay, I don't know if we'll be able to do that without somebody bowing out here. I think we have 10 altogether instead of, I think we're limited to 9 to be able to show video.
We are 9. 10 including me, yes.
Yeah, I think it's 10.
I can stand down if you'd like.
Okay, and you could check out my Justin TV channel. We're broadcasting it. It should come through there. I'm not guaranteeing it, but you know where to go for that, right?
Yeah, that's right. Thanks, Rick. Okay.
You should be able to hear there and go on.
Great, thanks.
Okay.
Take care.
You come back in later if you like. Okay, he's gone. Okay, so Geert, do you want to take over now and show us what you have to show?
Great. Video now?
Yes.
Are we in Belgium?
Yes.
Okay.
Belgium. Okay.
Zevenham, I presume.
Sorry?
You're in Zevenham?
Yes. Okay. The system, I think it's still a little bit too soon to show real stuff or real tests. We tried in the weekend some things, and yesterday also. But I show you what we were doing with the camera. I still don't have the container with hydrogen, so I made some hydrogen myself with the cells, and to load them in the core. Around it, we made some copper coil, see, and connected to an oscilloscope. It's a kind of flux detector or something. So when it spins and when there happens something, so we can see it on the oscilloscope.
Have you
Now,
produced any energy yet in any form?
no. The only thing we could see on the oscilloscope was 1 millivolt. That's nothing. It could be static electricity too, I don't know. But yeah, we can see something, but it's not much. We only tried maybe 3 hours maximum, so we have to try much longer.
What do you use inside to create a plasma?
Hydrogen.
Yes, but how do you ionize the hydrogen?
We just spin the housing, the reactor, and we don't have something inside yet.
So all you do, you put a hydrogen there and you spin it.
Yeah.
How do you expect to create ionization?
That's why I said it's too soon. We are not quite where we want to be, and yeah, I put in now the SEOs in here, and yeah, I still have a little bit leaking, so I fight always with the leakage. But yeah, the system has to develop more.
You see, the position is you have to create a condition where ionization and the creation of or the environment to create an open plasma exists. By putting hydrogen in there and rotating it, I don't know how you're creating plasma. This is what I don't understand.
Okay. What is leading the project? He is the theoretical man. He's online too. Maybe he can ask something.
Who is it?
He's online. He's a team member. Are you there?
Yeah.
Okay.
I'm here. So.
Can you explain how you're trying to achieve?
The problem was that we did not reach full vacuum, and the only thing available was hydrogen. So there are no other gases at the moment. So we first have to search for leakage, and it's not done yet. So
you still have a leakage in your.
Yes.
Where?
That's the problem.
Where?
So I think at the seals. I don't know. You have
at the rings or the top? At where the screws are?
I don't know. You have to ask Geert.
At the PS seals.
Where? Can you show us where you see the leakage? If you can take the camera forward and show me where it is, maybe I can help you.
Well, I don't know if you can see it, but yeah, the housing of the moment.
We don't see it. Can you show me where it is?
I have to look at the video also. Okay.
Underneath, that's
connection?
what I'm looking. What
Yeah,
are you
but
using there? What are you using?
to seal.
Yeah, what seal are you, what are you using?
Yeah, but this is not leaking. This is silicone.
Yeah.
This is silicone.
Where is it leaking then?
The flanks in there. But the leakage is in the between the feed-through pipe and the air seals inside here. It's a kind of
You might have to change your motor, but I think by the look of it, you have a strong enough motor. There is a seal in the market. I can send you where to look for it. It's like a flipper. It's got two seals together.
yeah.
And you put it inside at the point of connection, and you use what they call a space lubricant, and this seals any joints like this. Something I have to explain to all the people who are listening: be very, very what do you call it? Vigilant. This is one of the problems which a lot of people have with this. This is the biggest problem which all of you will have when you start running this system. You get leakage. The reason for the leakage is very simple and is overlooked by all of you. You set up your system with a seal to work in a vacuum. But once you create a vacuum, you start putting gases in. So the seal works in opposite now. That's why you get a lot of leakage. Always use two seals in reverse position back to back. You create a higher friction, which means you have to use a stronger motor. When you use a single seal, rubber seal, this is good when you create vacuum. You get a perfect vacuum. But once you start putting the gases in, the seal moves the other way. Now you need a seal back to back in reverse that stops the leakage of your gases out. That's why most of you have leakage in your systems. You have to use what is known as a flipper seal, which is a German-made, is a beautiful thing. It's like one seal, one unit, but with two flippers. One stops the gas going out, one stops the gas going in. So this is a misconception with a lot of designs I see, and I wanted to bring this out today. You set your systems for vacuum. And when you are vacuum and you're static, system works perfect. But when you start putting gases in and you bring in rotation, you get leakage because your seals are set in the direction of vacuum not to be released. Now you're reversing it. So this is what I do. And we learned this by experience. We were wondering for years why this is happening. And now we use it all the time. You need double seal, the same seal, not different, but back to back. Then you find all your leakages overnight disappear. This is something which all the designers have to watch, because I know continuously they speak about the leakage at the point of rotation. This is where your problem is, where you're putting the gases in and the unit is rotating. If you have such a thing, especially like multi-cores which we use, you need two seals, the same seal, back to back, and you house it, and you make a housing for it especially, and you fill in between the two gaps with what is known as a vacuum, it's like a grease for the vacuum seal that stays and keeps both seals continuously sealed. Otherwise, you have this problem as you have. When you start putting gases in, you get leak because your system works perfect for vacuum. But when you put gases and you change the condition and you create plasma, plasma puts a different pressure upwards. And you don't have one to control that, and that becomes a leak. This is the biggest problem you will face. You have to increase your flanges a little bit, and inside it allow for 2 seals. 2 vacuum seals back to back. You solve your problem. You have a constant, what do you call it, seal.
I use Teflon paste for vacuum grease. Is this okay?
We use all sorts. We tried all sorts of things, but different system works with different material. It depends on what you have. But if you use seals, especially the example of it is if you use thermomolecular pumps, you know at the point of your contacts you always have seals. It's like a ring seals you have to put between the 2 parts. Yeah, you can't put those dry. You have to use the silicone which rubs on the rubber. Yeah, you have to follow the same thing wherever you put a seal in. The same principle. You can't just put a seal in, so I put a seal or rubber seal or a silicone seal. A seal without some sort of a wax, which doesn't go into the reactor, it should be on the opposite side, has to be, because a fine amount of wax or silicone or what I call space grease closes that molecular structure. You need it. You can't just put a seal in and hope that it will stay, because there are scratches on your core, there are scratches on the seal, and these are the leakage points. When you put this seal or the grease, this closes this gap, and it really tightens the situation for you. You solve your seal, your leakage within a matter of few seconds work. This all comes by experience.
Mr. Keshe, you mentioned space grease a couple of times. Now, do you mean just regular vacuum grease, the high vacuum type grease, or something special that you know about this space grease?
I use this very special. We have access to special materials.
Okay.
You don't get access to. Yeah, it's part of research. You know, we work with different organizations, and they give you a package or a gift, as they say, "Oh, use this; it's better." There are materials especially developed by different, what do you call it, organizations as they see fit for their operation. So I have become a collector of, what do you call it, some exotic things which we use. So we call it, for the sealing, like on the rings, I use a very special seal. I wrote it in my last entries on the forum. These are special like silicon, which they don't release anything if they come into the core at high vacuum, because they become sources of hydrogen and other materials in your core you don't need. And one of the best ways to get rid of any interference from, if you're using silicon with the operation of your core, is to, this is a habit of researchers, is that because you put a system together and you create a vacuum, you want to test straight away. When you seal a system, and especially you use materials like silicon or any kind of things in the environment, you don't know if it's in the core or not, is to create a vacuum in your system and walk away, go for a coffee, go for a dinner, go for a sleep and come back next day, and let the condition of the vacuum to disintegrate if there is any silicon, to get all the hydrogen out of it. So then you create a second time or a third time vacuum, then you have an environment which you control, not other materials which entered or are there by accident. This is one of the things a lot of people who make these reactors, they immediately work with a wet seal, wet silicon, which they put around the ring, and because they did it, they can work with it. If you get a small amount of silicon just by accident going internally and become part of the structure internally, then that material over time will leak a huge amount of hydrogen, more than you put in there for testing, and you don't see the result. Always don't be in a hurry to do a test. First of all, most important things in your test is run your motor with your core for at least 20 minutes. That you get a constant, what do you call it, running of engine. We never stop motors once we start till unless they break or something happens or we decide to change. We run motors for days, for weeks. Because when you have, I've seen you bought the, what do you call it, the valves from the people in Ghent. When you have a high revolution valves, you can run these for weeks, for months. And you don't need, because every time you set up your system, your motor, you switch off, you switch on, you create an interference in the system. If you want to do a continuous test and test in different conditions of the plasma, never switch your motor off. You can run a motor for weeks. We run motors continuously 20 hours a day. Sometimes we come back in the morning, a piece has flown off and is broken somewhere, but that's mechanical failure. But you have to allow for all the factors, like silicon getting in. You might have some impurities. If you put the system together with hand and you did everything with hand, then you have a big problem creating plasma, because your fingerprint, which is fat, which is inside it, now that has to dissolve in time.
We also had a big problem with Teflon tape, because we've used that in some of our pipe thread type connections with hoses and whatnot. And what happened was the Teflon tape can come apart inside the hose, and little bits and pieces get into the check valve in the backing pump or roughing pump, and it holds open the check valve in the pump, and then the oil starts filling up the vacuum hose when you shut off your pump. So it was a bit of a surprise to me when I looked down one day and saw 4 inches of water, or of oil, sitting in the in their vacuum hose. So ended up having to take that all apart and putting in a manual valve instead of a check valve and whatnot. It made quite a mess. So just a bit of a warning for folks that are big into the Teflon tape. You have to be quite careful in the way it's applied.
I never used that, so I don't know.
Yeah, I hope to graduate to the proper vacuum connectors and hoses. That's the best way to go, and you don't end up using Teflon tape. You probably don't use Teflon tape, Mr. Keshe. Is that true?
I never knew. No, I don't. I don't use, no.
Right.
If you don't have access to high, what do you call it? What we call restricted material in silicon. Some of the high quality silicons you use in the bathroom for the tiles, clear one, not the white one, or even the white ones, they are one of the best things if you use just outside the rings. Those are as effective, but you have to make sure under no circumstances they come anywhere near the core.
Right.
You know, the high quality silicon you use for tiles and sealing the bathrooms, some of those, there are a couple of brands which are very good.
Yeah, less off-gassing with them, because they're used in the bathroom. You wouldn't want the off-gassing to affect
this is a special. Carry on. Yeah, with you, Gert. Sorry.
Holy cow, we got some interference there. I guess, is that from Garrett?
Can I ask you, how come you have these blue cylinders? Can you explain to us what they are? the blue units?
Okay, no, those two are bubblers for HHO or hydrogen. To make hydrogen.
What do you mean by bubblers?
Yeah, it's a thing I've been doing before I went to your technology, and it was a setup to make or to try to make hydrogen to run a motor or something, and they are
but
still there.
nothing,
They are still there.
nothing
It's
to do
not a
with your
part of
reactor.
the. Sorry.
It's not part of your reactor setup.
No.
Okay.
No.
Nice.
I used this piece I saw on your
Yeah.
video. You had it, yeah.
Yes,
But
yes.
mine is leaking a lot.
There
It
are
don't
two
work.
problems. There are two problems with these seals. I know you paid about 70, 80 euro for it.
Yes.
You've been to, what do you call it, to Air Compact. These units, you always have to put a 90-degree valve to it. And secondly, if you bring it up, I'll show you. If you bring the valve up, where you see the rubber,
it's not a valve actually. It's a feed-through. It's not a valve.
Yes. No, this is correct. This is 100% correct. You see where the hole is? Just underneath of it, there is an O-ring. If this section of the O-ring shakes too much, they lose their sealing capacity. So by putting a 90-degree and locking your core, you have to stop the vibration at this point. Or the other thing which I do to stop, because these are expensive parts, for 80, 90 euro for half a day test is no good, is, do you know when you attach, if you bring it up, I'll show you, bring that up. At this junction point where the hole is,
yes.
When you create a vacuum, try, if you can, to put, what do you call it, silicone around it.
Yeah.
Just cover it with silicone, even though it rotates from just above the flange to the other side of the flange, covering that hole. If you cover it with silicone, that stops the leakage. But most of the problem with this unit is the blue part. Anytime you put a tube in, you can't just push the tube in and pull it out. Even when you push the tube in, the 6mm tube in, you have to pull the blue piece back, that it releases the hooks. If your hooks gets damaged because you push it in and out, you lose your vacuum condition. This is important. Anytime you use any of these kind of seals, especially with this blue section on the end, when you put your 6mm tube in, you have to pull the blue piece backwards, that it releases the hooks inside. Because when you pull it back, it's open, you put your pipe in, and then you release it, and the hooks literally digs into your pipe and creates 100% seal. And a lot of people get this habit of they can just push the rubber in, and then when they want to release it, they pull the blue back. The blue piece has to be pulled back all the time. When you put a rubber in, rubber hose in, and when you take it out. If you don't watch with that, you damage the thread and you get leakage. And that's majority of the problem with this, all this, not just this, but most of the retractable engagement rings are. People, just because they think they can push the tube in, is pushed in. The worst thing is when you push the tube in, pull the blue rubber back, that it opens the close. And then when your pipe is fully in, release it, and then it grabs, you get no damages. The other point, especially using these claw grippers, is that Once when you put let's say the 6mm tube in and it locks, and then you take it out to do something and you want to put it back in again, you have to cut the first ½ centimeter of the tube.
Yeah.
You can't use the same position tube again. So when you're setting up conditions where you keep on replacing or pulling the pipe in and out with these closed systems, choose a longer piece of pipe, because once you remove a pipe to do something and put it back in, the claws of these retractable conditions have already dug into it, created a hole on the skin. And you never get the exact position back again to be in there because you're not in the claw. So always cut your pipe by ½ centimeter, that a new position is attained by the system when you put it back in. This is a lot of leakage which people don't understand why my pipe leaks. Because you can't use, not even twice, the same pipe in the same position. These are fantastic units, but it took me about 2 years to find out how to work with them properly.
Okay. Okay.
These
I
are units.
I tried to open it with the screw in here, but it's
you can't. No. It's sealed internally. The way they do it, I think they build it inside out, and the screw, I think, it snaps inside or cuts itself off, then nobody can open it. I've tried it; it doesn't work.
No.
One of the best things to do if you have a machine, you know, these sharp, like diamond cutting blades. Yeah. Try to cut one open, put it on a jaw, and cut this system open, and you see how beautiful internally is. Then you know how to handle it. If you got one damaged that you can't use, it's a nice thing to do. But these are, when you use any kind of feeding pipes, which you have to get in and out or replace it or put it back in, just cut ½ centimeter from the pipe every time. You save yourself a lot of problem.
Mr. Keshe, I have another question.
Yeah.
I saw the upload from your video on the forum of the startup of the nuclear reactor. What we were asking to each other, what was the goal actually that you show this video?
A lot of people have not seen how a reactor goes into operation.
Ah, okay.
This was put in because, you know, we can't use nuclear material. So we put it in for people to see when you start up a reactor at high power. And this is just for knowledge. It's no use you working in what I call non-nuclear, nuclear environment and not knowing what is going on. I used to get involved a lot with putting things like this or to do with Fukushima, what was happening. We stopped doing it because of the involvement with the research and other parts. But I thought that was a very good thing for people to see. In reality, what the color you see, which gets created around the plasma, around the reactor, is partially plasma. It's mainly plasma. And this was one of the things I wanted people to see, because this is one of the major problems, or will be one of the major problems, and it's one of the things which people who work with, like you, and trying to do the system and copy the system, is you as a general public do not have access to nuclear material. You cannot get access to nuclear material. As you know, our material was confiscated by Belgium Nuclear Center. In my lab was kept and then was removed and destroyed last year. And so we went, it's something I knew for years. We went to look into the operation of the reactors which create the condition of plasma by creating the environment for nuclear condition. In fact, the new generation of the reactors which you work, if you cannot create an environment to hold on to a continuous high level of active plasma, running these reactors will not work unless you have nuclear materials. We used to carry something like nearly 400 units for one test, which is a huge amount. Controlling some large 400 units of active nuclear material for one test has huge amount of health hazards, if you don't know. So if you look at the structure of your own body, if you look at the structure of the Earth atmosphere, if you look at the structure of the boundaries of this solar system and in the galaxies, you will find out you don't need nuclear material. One of the reasons I put this video on was to make a joke, or in a way to laugh at the whole structure, that the time for this kind of nuclear material is finished and over. You have to look in your reactor, you have to look in the design of your reactor, how to create a safe environment where ionization at a high level, rapid level can be created. It would not be done. A lot of people write to me and say, oh, we found out how you do it. You create a vacuum and hydrogen, high vacuum releases blah, blah, blah. You try it. A lot of institutes have tried it. You have to look into an environment, creating an environment in your reactor without any nuclear material, the way we have shown in our system, that you create a continuous condition of ionization, extraction of the energy, creation and development of new materials. That at the same time, ionization and plasma expansion can be maintained. We have developed this, we passed this stage. This is something is written in the patents. People have to read it. In the first patent, it wasn't in. When we modified the patent, because the world patent or European patent asked us to rewrite the patent, because of the time gap of 6 months, 2 years, whatever it was, we developed the technology so far that it's in there. If you get hold of the original patent and read the revised version of the patent, I have given a very clear indication how to create the environment. So by rotating and creating a core and putting hydrogen in, I don't think it's achievable. That's why we allow you to go. We allow a lot of people, the cores are going. I just saw the Maltese, they have developed a new reactor. I saw it last night, they sent it to me. It is beautiful what they created, like yours, you put a lot of effort in it. But the position you are in has to be a condition that you can create a continuous plasma without any electric charge, without any input of current, without nuclear material. So go back and look at the structure of the Earth and your own body. The answer sits there.
Okay.
A lot of people I see are doing and creating these, and they say they can't achieve energy production or motion. Is what I tell them is very simple. How do you expect to just rotate a hydrogen on its own and get something out of it? First of all, you have to ionize, and secondly, you have to open the plasma. And this
Is
needs...
that why you use nitrogen in your stars formation?
I use nitrogen in a way, yes, because there is a book coming out. It's a book number 1, or first part of book number 5, which is a medical. In that book, explain the function of nitrogen. And if you can get hold of the presentation I did in Bulgaria, I explained the function of nitrogen in the whole structure of human body. Nitrogen in upper atmosphere allows release of extreme ultraviolet. But when you add other materials and you lose your vacuum condition, it does not work. We tried it. We have tried nitrogen very heavily. This is what is missing from the patent is the new discoveries of what we have discovered and the materials which are continuously developed, which allow the creation of extreme ultraviolet on a continuous basis within the structure. So we don't need nuclear material. This is again thanks to the, I should say, Belgium nuclear authorities in blocking me. I brought the technology forward into a non-nuclear by about 10 years. Because this way, when you start using the new materials, you have no nuclear, you have no need for nuclear material. And secondly, you create a condition of plasma and ionization at the point you need and the amount you need. So by creating vacuum in your core on its own and rotating it and expecting continuous production of high amount of energy, this is a bit too far. I don't understand it. Maybe you have to explain, you discovered a way I don't understand. Or as I've seen with
gases.
With Rick, is he uses different ways to create a plasma in his system, as we've seen in the first lectures or in the first workshops. You need to maintain and create environment which ionization, plasma opening is part of the structure, not as external unit. We will release the knowledge in the steps as we test different materials. So you have to look, I'm looking into how a lot of people, there is a lot of information around the huge, what do you call it, internet, that they say nobody has managed to successfully create energy with my theory, with my work. Yes, they have. NASA has. We know NASA has. We know other agencies who have access to nuclear material they've done so. We used to do when we had access to nuclear material. So your work looks as negative, but in a way I have to let you to develop your own ways, and in due course we release you the material, because this is not my knowledge, this is yours, it belongs to all of you. So you have to understand all the pitfalls and the way you have to set up things and do things. And the new materials which we develop and we have developed allows full operation without the existence of nuclear. So I hear people say, oh, hydrogen at high vacuum releases. The minute you put a small amount of hydrogen in your core, your vacuum condition is not there anymore. You understand? So first of all, feed your hydrogen even when you know, in a very, very small amounts that you allow ionization. You can't put in a 1 centimeter of form, what do you call it, a 6 millimeter tube and run a core. That's billions, millions of atoms inside you want to ionize. It doesn't happen. We start with a very, 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 very small, minute amount of hydrogen and run the core for 3, 4, or 5 hours, even with the new materials we release. That you create a pure, what do you call it, homogeneous plasma. Then you can play. This is one of the pitfalls. People set the reactor up and then they run it and they look for the measurements. You're not the only one. I used to do it. Expect results. But I've learned over time that to get a perfect condition, perfect results, look in 2-3 days working of the system. Go for a coffee, go on a holiday and come back and you see your plasma is made beautiful. It's a cooking pot. You got to learn, and once you started, then you can play games. I've seen all sorts of comments, you know, he plays with a gauge, he's done this, he's done that. We put videos on for people to see. We don't put in there to listen what people tell us because we know what's going on. We run a system. This, as I put on the forum, I don't know how you're measuring the flux, but the only way we see effects of the energy and a magnetic and gravitational field is by suspending the whole unit on its own without the effect of the motors, where everything runs but it's suspended in air. Then you see totally different results. I used to do what the framework you have there is similar to what I used to run, but because of running these units, I learned the next step, or I developed the next step. And you have to look in, maybe talk to Rick, how Rick creates plasma in his reactor and how you can do it. You have problems that you have to hold your plasma inside the center of the core. So this is what we recommended layering, because the minute your plasma touches the core of the body, of the steel you have no plasma. It's gone.
Yeah, that's what we found out is the plasma seems to like anything metal. It'll tend to just dissipate into it more or less. And
the worst metal is stainless steel. It's one of the problems with it. So try to create that layer of helium or nitrogen, a small layer. It's I was explaining this to somebody. You know, Indians, when they have curry, if we in Europe we eat curry, we get problem with our stomach. And Indians eat curry, or South Americans or whatever eat hot chilies without any problem. Indians have solved a problem with yogurt. They take a spoon, we see it, they call it lassi or whatever they eat as yogurt. That yogurt gives a lining to the stomach that the hotness of the oil of the chili does not touch the lining of the stomach. You got to do the same thing with your reactor. You have to create a lining that the plasma never touches the wall. And if you have probes into the center of the core, your probes have to behave as they are not there. You have to create the same condition around them, because the plasma is in the center, and I've seen people putting a central column in. So where does the plasma supposed to work without touching this central column? That's why I spoke about the retractable columns, where you can do things. You have to create two things, the environment or the material, that your plasma cannot touch matter.
Is it so, Mr. Keshe, is it so that the new core you made, are they of copper and treated like the cola bottle, so there's inside?
That's the old system.
Okay.
That you have problems. That's the old system. We are developing new materials. It's like very much like a dust, but it's a dust which does not get extracted by high vacuum. because the maglev of the dust internally is so strong, like an adhesive, that the high vacuum condition cannot extract it. So we created like a honeycomb. It's like a holes. It's like a a maze of holes, but the material is stick together, and you cannot touch it. If you touch it, you destroy the structure.
It's like SP2.
No, no, no. It is GANS. It's a GANS. It's very much GANS. It changes its property according to the material we put in the core. If you put hydrogen, the material behaves. Yeah. If you put nitrogen, the same material behaves different and it gives you the same result. So you become independent of the material which is in the core, but you get the same result. It's taken me nearly God knows how many years to develop this. And this material is literally like powder. You cannot touch it. It takes me sometimes up to 2 months to build it. To use for a reactor, to set up a reactor. They said, you saw the core in 21st of April presentation. From that point to make it ready for even the first test to build up the structure internally took 2 months. It's not something you just go in and you do it and you come out. And it's been a lot of error and development.
So
is that the triple core?
Is it? Sorry.
Yes, it is a triple core. The triple core, yeah. So even the core inside the core is invisible to the plasma, because the wall of the material helps to create a plasma. So this is how layers are built in the center of the stars. This is how gravitational magnetic fields of the stars are so heavy. We don't have solid core and inner core and outer core. You create a condition inside your reactor that your wall of your cores internally are part of the layer of the magnetic gravitational field of the system, not the separation. This is the biggest mistake people make with their multiple cores. Your internal core, if it's just, or your probes or your central columns are made to be there and they are not part of the structure, you lost it. You're at point zero before you start. You'll be at point zero forever. So we don't see solid pieces in the structure of the solar systems, in the structure of the stars. The separation, magnetic field, gravitational field strength. So you have to repeat that into the structure of your reactors. This is a process which takes time to set up. Even if you can put a nail in the middle of the reactor, in the middle of the plasma, hanging. But if you processed it the right way, if you created the right material for the nail, it could be made of steel, copper, it could be of aluminum or cotton or wood. If you created or treated or processed the system, that piece, that it doesn't become an outside object, but it becomes part of the plasma because it creates the same environment around itself, then you can run reactors in any condition and anywhere with any material. And this is what we are developing. This is the new development, and as I said, thanks to SCK and thanks to the nuclear authorities in Belgium in pushing us, and I could see they're going to do this. We brought the technology forward by 10 years, but it was sitting in our books for years. For years it was sitting there. I knew one day it'll be needed, but I never thought I'll use it so rapidly. So now if you start with a reactor with a core, you have to create 3 conditions. Your plasma never comes in touch with the wall of the reactor. You reactor, your core, has the capability to create and maintain ionization and plasma. And the third is you find a way that you can extract or allow this plasma to be used. It's no use creating plasma and leaving it in the center. You can use it for energy, you can use it for material, you can use it for motion. And this is what I put on the forum yesterday or the day before. This is the next step for this target. So just because you create a vacuum does not work. With the SP2, SP3 does not work. You have to create a flexible, and that's what I said at the beginning of this talk today. You have to be able to create life anywhere in the universe with the material you have in hand. You have to be able to create energy anywhere in the universe with what material you have in that position. Once you know how to walk, running and jumping should be very easy. This is the next step for the people who are working with these reactors. You have to
So is
create...
it correct when I say your core layering of protection is in GaN states of hydrogen, oxygen, nitrogen, and carbon?
No.
No? Okay.
And yes.
Just a question.
Yes.
Try a few elements, few other elements, perhaps. We can eventually.
We tried CO2 in Tehran. We tried carbon. I have tried what do you call it? Argon. And once you understand the process, you can use anything. You get the same result.
That's what we want to do, to understand the process, Mr. Keshe.
Yeah, but the thing is, you have to allow us. In the nuclear side, we could do it, we could explain it. We are on uncharted territories at the moment with non-nuclear material. We have to understand, we have to analyze data, and analyze these data which are coming in through the test. And literally, I wake up in the middle of night and analyzing why and where and how these things happened. And I ask our consultants, I ask the people who we take advice, scientists who work with us or scientific papers around the world, to see if the line of thinking and the work is correct. We are developing new materials. These new materials takes time. There is a process. I've developed a shortcut very recently in past few weeks. But we have to see if the shortcut works. Now we will be running 7 reactor cores at the same time, and I'm sure there will be different type of what do you call it, processes involved. Because I've seen it is sitting on the table, and our team are building the parts for it, and hopefully we start again next week or the week after. Then we will test something like 20-30 different materials. One of the things which is going on, we know very soon, we will invite you to come in. People like Gert, or people in Malta, or people in China, we invite you to come into the lab, because now we are open our knowledge to you lot.
What about America?
You're quite welcome.
Thank you.
You're quite welcome. You're as good as us. You are no different than the rest of us. You just carry different name for different part of the world. We have respect for you and we honor you. The problem is, let us learn the new process of non-nuclear. We are inviting governments, we are inviting officials to come and have a look. And I think Keshe foundations around the world have the priority to this situation. But this is, there are people who are literally working more or less around the clock till 1, 2 o'clock in the morning, putting things together that we can test these materials. It's no use telling you something, because I see people working on different reactors. I'm waiting to learn from you lot. I don't know everything. I know everything in principle, but I don't know how to work with materials. So I'm learning the working with materials. And these new materials, because I understand how to create them, is much easier for me. And when I finish with it, as I said, the man in the jungles of Africa will do exactly what the professor does in the university in, what do you call it, Chicago, or in Paris or in Tehran. Because the process is very cheap. To produce these materials doesn't cost millions. It costs a few cents. It's not that because they're exotic and they work as a superconductors and superconductors, they have to be costing billions. To produce material for the core like you have behind you, Gert, it costs, I think, about 3 cents. Maybe not even 3 cents. But we have to understand what this material does. How does it behave? Yeah? Then we can pass it on to you. We run reactors, we run tests. As you know, the governments in Europe are working to literally shut down the website of the Keshe Foundation. All sorts of tricks has been played in past few weeks for you lot not to get the knowledge. And we are spending huge amount of money keeping the foundation link open with everybody, that we can pass the knowledge on. There are governments who are buying servers around the world to bring the foundation server down, or hijack the domain, or do all sorts of things. So let us do our work. We invite the governments to work with us, and these things will not have an end. Because once we release a technology, it's not the energy, it's the medical application, is the health application, is the producing new materials and producing new space and motion systems. And let us test. We are testing, we are very rapidly developing, and you don't need to spend billions. It's what I said in the last, workshop. People look at the Coca-Cola as SP2 and SP3. We showed that to the people who understood what the threat this Coca-Cola bottle can be as they thought. But in a way, I say thank to you Americans, by Coca-Cola and the Pepsi-Cola, you allowed the whole world to have access to free energy. The bottles these things are carried in, yeah, is the energy resources which we could never imagine to have access to. These are the sources of your plasmas. All you need to do when you have a Coca-Cola, put it in the bucket. We show you how to do it, release the hydrogen in less than 1 cent, which is all over the place. Then use that hydrogen rapidly within that system to become a plasma before it comes into your core, and that's it, you see your energy system. So, and the other thing which we are looking at, maybe in the future is practical to do, the Coca-Cola in tins, because of the material, is one of the best reactors you will ever have. So, in an unknowing way and in a special way, we not only we help the environment, we can help ourselves into future resources on this planet. But Keshe Foundation is not involved in this. We are looking into the deeper space. And very soon, as I said, we'll start allowing. The biggest problem for me was to allow people to come into the lab, to see what we do, to see how we operate. And in being forced or put on exile by the Belgian government that we had to leave Belgium with the pressures from other governments, and coming into Italy, we open our doors to outsiders, other scientists, other researchers, other engineers. So my biggest thing was to keep the technology I developed, I released in small measures as I needed, as I wanted. Now that I opened the door to the Italian scientists and Italian engineers, why not the rest of the world? So you all, we invite you in groups of 1 or 2 or 3 or 4 to start coming in within the next few weeks. You bring your knowledge, you come and learn from us, and you go back and you share the knowledge with your nationals, with other scientists.
Okay,
Because,
Mr. Keshe, can I ask you something? I have a group also called Visiting Ninov. Should I change the name of it?
You call what?
Visiting Ninov. Should I change the name of it to Brescia or something?
There are things which we have to do to be able to secure certain things. Yeah. So once we finish with this, hopefully within the next few weeks, we have told to the people from Hungary, from Bulgaria, and from Ukraine, and other places which are setting up their Keshe Foundation. We invite you to come in. And one of my targets is when we allow like groups of 6 or 7, not to be one nation, one from each nation, at least 6 or 7 people at the same time. And we don't want visitors, we want scientists or people who are working on these cores, that they can go and practically do something with it. This is not a NASA tour from outside, there is a rocket there. You come in like the Italians, like the Iranians, you put the gloves on and get on with it. You decide what the test is going to be. And within minutes, we know how much you know about and how much we need to teach you. So
yes, and the group was intentionally made for to write about the experience with the visiting of Ninov. So it's
no, you come
to share.
And the experience with us is you get on with it. You stay here 2 or 3 days, 4 days, whatever, and you run tests the way you want to. This is not a tour of what we call McVitie's to come and see how we make biscuits.
No. I call this group to share the experience of test and something.
Yeah, but the sharing, just 1 second, please, just 1 second.
Hey, Rick, or Geert, should maybe we drop the video and invite the people back that couldn't be in here?
Which people?
Zaizan.
Well, I'd like to also show video, and maybe we have some other videos.
I'll put a video, maybe also.
Say again, sorry?
Do I have to stop my video connection?
You have to stop it now?
Okay. Oh yeah, if you're going to another video.
No.
Yes.
It's about the connection. I asked Rick if it's necessary to stop the video to have a better connection.
No, I think we have a good connection. It's a matter of if we bring more people in, then the video won't work over 9 people, I believe is the limit. And we have 8, 9 now. So if we were to invite someone else in, we can't do any videos. And I don't think that's right, because right now I'm broadcasting to Justin TV, and I think Zaizan can hear what's going on there right now, as far as I know.
Can we see some other videos? Anything else you want to show?
Yeah, I'd like to show a little device here. Maybe I can get into that now. Okay, so here's a little, let me get set up here a little closer. And put our background piece of paper in here. So you can see a little better. So what I've got here is a concept reactor for what maybe a future Keshe reactor might look like, you could say. So what I have here is it's actually a plastic sphere inside of the plastic container, the chamber, vacuum chamber. And this levitating right now. It's magnetically levitated by a magnetic base. It's a Levitron type base. So it's a plastic sphere. It's got a magnet inside that allows it to levitate. And it's rotating according to this levitation that it does. There's no upper bearing or lower bearing. It's completely isolated by itself, rotating in there. And what I've done is I've rigged up a little copper tube in the top there that's attached inside and goes out to this valve here. And what I hope to do here is I can open, there's a vacuum inside of this chamber right now. Well, there should be. I think I have to open this up. Oops. There should be a vacuum in there now. I'm going to open this valve, which will allow air pressure to come in through this valve, in through this little tube, and it should change the direction of rotation of this sphere. There it goes. Whoops, it's getting a little out of hand here. It's a little wobbly. We don't have the magnet on the top as the stabilizer magnet. Okay, now I can open up this valve a little bit and get this rotating quite quickly in there. It might get out of hand and crash, but that's why it's a reactor sort of in process here. Whoops, it did crash. Okay, so the idea is that by controlling the air pressure essentially through this valve, we can control the speed of the globe inside. Once it's stabilized, you can actually, we got it up to 500 or 600 RPM just playing around with it. Once it's stabilized, it's conceivable it could go thousands of RPM if it was properly stabilized. And so that's one feature, is the controllability using air pressure rather than any kind of magnetic drive or motors. There's no motors involved, so we can just use air pressure to control the speed of the globe. Now the other function is I've got a Sept seal on the top here. Let me see that. Let me raise this up a little bit here. No. Well, yeah, I can kind of see that, but then we won't be able to see this. So take it back a little bit so you can see this. Out there, yeah. So what I've got here is I've got a hypodermic syringe, and you can imagine if we had some hydrogen inside of here, and we'd only want a small amount perhaps, but for demonstration, if there's still a vacuum in here, we'll see if it is. I'll put this through the Sept seal and see what happens here. There it goes, slowly. See how it goes? It feeds in on its own with the vacuum. If there's more of a vacuum, it goes a little faster, actually. So now we've injected some, say, hydrogen or other gases into the chamber. There's also the possibility of going deeper with this, right down directly into the sphere as it's rotating, to be able to inject any gases or even withdraw potentially from the sphere itself with the septa on the sphere. So you go through doubly into the chamber or the sphere, and you can alter the gases in the chamber or the sphere through this, and also through the other tail we have here, which gases can also enter in through that way. Anyway, this is kind of a concept that I was playing with as a potential future reactor. I don't know how much potential it has, but it's more of a conversation piece in a way of just showing some of the concepts.
We have developed this system in a double core, and it works very much similar way, that the core inside, according to the gases you put in and the vacuum condition you create, rotates in one direction or the other at different speeds. And when you rotate, your core is cylindrical, the external core, but our core is spherical. So you have two spherical cores inside each other. which they are independent using the valve which Gert showed us. So the inner core rotates on its own. This was built for experimental reasons when I was in Tehran, and while I was there, I decided to do a test. And what we did is we ran one core in the middle, the main reactor, and we ran this system, which is like yours, with one core inside suspended in a distance from it. And whenever the vacuum, or what do you call it, the magnetic gravitational field of one of the systems reached a certain strength, this unit used to fly, and I used to catch it. Like, you know, you play baseball, you catch a ball in the air. This is why in the star formation now we secure everything to the ground, to the plate, what we call the ground level plate. That we don't go play baseball in the lab.
Well, speaking of baseball, that brings up another reactor concept that we've been working with here. I'll just show briefly. We don't have it set up, but it's. I'll show the concept. Maybe Guy can help with a bit here. This will be the top plate of a vacuum chamber, and I call this the ping pong ball reactor because it's got a ping pong ball as the.
I used to have those years ago. I still somewhere in the archives in our material.
What? I thought I would be the first. Oh no, it's already been done.
This
it's already been done. No.
We showed this for the first energy production from plasma, the ping pong.
Oh yeah. Well, this is a different twist on it, so to speak. What I've got is a motor on the top here, okay, attached to the ping pong ball. But this motor is special in that it's got a hollow shaft on the motor. It goes right through into the ping pong ball. So the whole thing rotates. And then I can put a Sept seal on here or a rotating seal to go into the vacuum. And I got this rigged up to... it's a pulse width modulated motor, so it's got all the system here ready to plug into the 12 volts. I've already had it running, and it's controlled by our famous controller here, which can control the RPM, and it's got a RPM gauge and so on that can go on the whole thing, and so on. So the idea here with the ping pong ball reactor is it's a direct feedback system. It doesn't need any sensors because if you see it glowing, then that's a good thing. That means something good is happening. If you see it melting, then that means you're getting excess heat and you better stop in this case. If you see it completely disintegrating, well, you probably hit the mother lode of energy systems and it's time to go to a little more secure wall perhaps. But we actually tested a ping pong ball can take full vacuum. So I was pretty impressed with that, and I'd like to do more tests with that.
We wouldn't mind playing baseball with a ping pong ball too.
No, but when you run a multi-reactors, multi-cores, you get this. That's how solar systems, the planets find their position according to their strength. And as we're testing condition, sometimes you create a condition without knowing, and you find your reactor just because it's a free floating, it just flies. And even the direction of flight, you can dictate which way you want to fly it. So the new system, which is sitting for a star formation, everything is secured within frames that we don't need to play. So we keep everything into the special plate we made. It's about 1.5 meter diameter. So it's designed in a way that we can position the cores anywhere on the plate and allow 2 of the cores to even move within the same plane, up and down. So it is, what do you call it? It's got flexibility in the motion of the reactor. If there is a force on it, it can move to a position, and we can see why it's moving in a position. It's like a, what do you call it, a maze where you can move in different channels. So the reactor can find its position within the maze, or the space of the maze allowed. So we take
Are
the
those
flight.
the single cores?
One is a double core and 2 single cores.
Yeah, but
Mr. Keshe, about the multiple cores, are they rotating in the same direction, or?
No. It's very strange in the test when you do multiple, then you will see that your cores move with the speed when you reach a level of plasma in different cores, because sometimes we vacuum one core and we play with the other core, or we allow different materials in different cores and we dictate the speed or direction of rotation. And you see sometimes reactor core on its own, it comes to a halt and it moves totally the opposite direction, and your motor becomes a generator. So you see things, and you follow the pattern which the forces within the core dictates. But our system is set up, any core can move in any direction, any speed. So motors are independently controlled, reactors are independently controlled. We can switch one off or put two to work at the same time together to work against the force of the third one. The reactor you see in 21st of April, when it's completed, which is in the stage now, we control more or less every movement and every motion. And the next video you will see is totally different structure than before, because now we are going into the energy level test, and for energy level test we should be able to dictate in what do you call it, very much not power from the reactor. You people connect electrodes into your reactors or see how much energy comes out of it. But as I said, these are receivers. You can lock into another receiver with it, and you take the energy from the other receiver as much as you like.
Mr. Keshe, you control it wirelessly? The motors?
No. We control everything. Everything is on a 10-meter wire. All our pipes, all our things are allowed 10-meter movement, where the platform can lift and move. So nothing is rigid. Once the reactor starts moving, or we move the reactor, you don't have to run and chase and do all sorts of silly things with it.
Why are you not using wireless?
You cannot reach the system internally. We know that from the systems in what they call it, in the nuclear tests. Once you create a plasma internally and passes the boundary, you cannot enter. Even the wireless system, the wired systems becomes a problem. Unless you come into, if you go back on the video, people, I think if you listen to this, go back to the video which we put in on about the reactor a few weeks ago. We showed the weight reduction and weight increase.
Yes.
If you look at it, it's a ladder frame. Is hanging off a ladder frame. What this means is that once we reach, because we had this by experience in the nuclear, so this time we solved it this way, is that once we reach the lift condition, we move everything within, we got something like about less than a minute or a minute. We move everything on the platform on the ladder, which means we become part of the system. So we don't need to be wireless. So the structure, if you look, is a platform structure. And in sides of the reactor, if you look on the frame where it's hanging, you see all the gas cylinders already attached ready. So we don't need to be dependent on outside. You only need a small 9-volt battery or a 12-volt battery to run the system if you're supporting it, but the system feeds itself. People look at the structure and say, oh, this and that. The structure is set for flight. The structure is set for extracting energy. So once we reach the point, what happened, I learned that with the very first motion of the reactor in Tehran, I jumped on it, and I damaged the system. This time, now we have more experience, we've done it before, we made a frame, ladder frame that 2 people can get on it and stand on it. We become part of the system, we don't need to be remote. So we have solved all the problems because we see it with the nuclear side in a non-nuclear system. And everything is on 10 meter, on the 10 meter range. We don't stand near the reactor, we are 2-3 meters away from it usually. We try to keep away as much as possible for any possible radiation or any, what do you call it, anything we might create inside it. Doesn't need to be what do you call it, nuclear, is radio waves or whatever. So just don't look what we show, look at the whole structure. You see 2 black bags which are sitting on the table on the top, which is the first picture when you see the video. Those two bags carry 2 radioactive, what they call nuclear radioactive detectors. If there is any radiation created within the environment and around the reactor, we immediately know we have to shut down or we're going to a certain level of radiation. We monitor because they make continuously noise. We are aware of the noise in the background, like in nuclear power station. Everything you see there is been set for something. We especially hung it on that frame of scale for certain purposes. Now it's gone back on the digital, what do you call it, load cell. You don't have access to these kind of facilities. We buy systems to do things, and now we allow you to come and test what we test. This the new system which is getting up for the what I call the star system, the mother system, is because we saw problems which wasn't foreseen in design and in testing of before. So we allow you to come in and see and test and see what we use, what facilities we have. Hello?
Mr. Keshe, I have another practical question about vacuum or vacuum pumps. I still use the 2-stage pump to create a vacuum inside, and I have 10-3 millibar. Do we actually need? Sorry.
Can you repeat? I couldn't hear you clearly.
My 2-stage pump creates a vacuum of 10-3 millibar, and my question was, can we continue with this vacuum condition, or do we need deeper
What do you go to, -10-3?
Yes.
Go back to air compact.
Mm-hmm.
And you can buy a system from them. It's a small pump, tabletop. I think it's 300-400 euro. You can go to -4 or 5, 6, 7.
Okay.
Because -3, the minute you put gases, you're vacuum, you finish. The higher level vacuum you can go, we go to -14, -15 with the molecular pump, which has been developed for us. And then we are allowed to work in a much higher, better environment and a deeper vacuum. So -3, the minute you start adding gases in, you lose your condition.
And the speed, is it dependent of the vacuum or not? The
In some
rotation,
cases, yes. In some cases, yes. Some cases, no. In in the lift reduction, we deliberately keep the speed at 500 RPM because I don't try to go into centrifuge 1.5, 2, 3,000 because we don't see galaxies rotating at that kind of a speed. You can create conditions with 10 to 15 RPM too. The speed is it's very much what you want to achieve. Highest speed. A lot of people look at the highest speed. The higher the speed you have, you achieve this and that. Not necessarily. I have tested around 100, 120 RPM, and I get the same results as 1,000 and 1,200. Depends what you want to achieve. As I said, it's the condition you have to create, and you got to see what your system allows you to. A lot of people I see they put very, very big motors on their system, and they think they can force centrifuge condition. Centrifuge condition is to separate the material in a layer of the heaviest to go to the outside. When you have a high vacuum, you achieve it. You don't need rotation. You understand? So then when you have vacuum condition, high vacuum condition, which gives you heavier gases on the boundary, outside boundary, why do you need the higher speed rotation?
Well, because I spend it at 4,000 and it's a little bit scary and dangerous too.
Then I seen somebody send me an email, or I read somewhere about somebody's test who created the blockage with a telephone line or something. Was that with yours?
Telephone, no.
No, somebody, I've seen an email somewhere. Somebody was saying that when they were on the line to you or somebody else that...
it was with Sept, maybe.
Yeah.
We had a Skype connection, and well, we did something, but it was only with air and vacuum. We tried something, and yeah, he gets from my camera waves in the picture. We didn't know what it was. Maybe nothing. I don't know.
But could you repeat it?
We did some tests online with the camera. I spent it 10 minutes, 10 times 10 minutes, and vacuumed it and loaded again with normal air, actually, atmospheric pressure, to try something. And suddenly there were waves in the picture. I couldn't see it. It's only he told me.
Can I ask you a question? Why have you put those copper rings around it? Can you explain to me?
Yeah.
To us, because I've seen people asking you that question on a forum somewhere.
It's a spiral around it, and it's connected on an oscilloscope to we thought to detect flux or magnetic fields. It's maybe a way to see when something's coming or happens. That's all.
I think you will see it if you create the right environment in the reactor.
Yeah. Okay.
I think you will see it. You will see on your oscilloscope, and you will see it on your voltmeter or ammeter. What do you call it? The effect. What we've done, I think you've seen it, or somebody has mentioned it before a couple of years ago. We've developed a half-sphere generator, or what do you call it, coil, for a generator that sits on top half of the reactor. So the whole core rotates inside this half-sphere. It's like a helmet. And we have 3 winding circuits with it, which means we can take 3 phase out of it. And we've seen power production in the nuclear test from the motion of the plasma internally in the core. So I'm sure if you place it in the right place, right position, you will see effects when you create the plasma. And one of the best ways to do, you have put the core in around the circumference of the center line of the reactor. Yeah. Twist it a little bit in an angle that is not the way it is. Put it at about 10 or 15 degree angle around the core. I think you'll see very interesting results.
Okay.
Yeah. Because the way you set it, you wait for the rotation of the plasma in one direction. When you put it tilted slightly 5 or 10 degrees, you cut more flux lines and any variation of flux across the lower and upper core. You would realize in test, if you can put a connection to the upper hemisphere and the lower hemisphere, that the current flow is not the same. It's different. The weight of the plasma or central material of the plasma, even though you have a homogeneous plasma core, has a different current flow in the southern hemisphere than the northern hemisphere. Very slight, but it's very interesting to see it.
And the weekend we did some tests with the team and to prepare for today. And how do I say?
You are very rough. Can you speak louder?
Yes. We did some tests in the weekend with the team in here in Zweden, and suddenly the upper hemisphere was different temperature than the under hemisphere. It was a few degrees difference in it.
This is correct. This is what now you would test. You see, write all these things down in your test, and you see it. When you tilt the coil that it covers part of the northern and southern hemisphere, you automatically create the difference in the flux that you need to get a flow. Where the way you set your ring is constant same position. But northern hemisphere is done in the southern hemisphere, and then you see a flux change, and that allows you to see current flow as well.
Okay, I'll do that.
Yeah. Okay. Anything else?
I got a question. Going back to the nuclear reactors, is it the sorry. Is it the mathematics still stand for the measurement of the gases and everything else?
Explain. I don't understand what you're asking.
I'm on my way to make a program, small program on Excel or something, which will give you right away, let's say for a certain volume of a core, the amount of the gases you need to be very easy to create the conditions to run the reactor. And the amounts for hydrogen and nitrogen and everything else are different. And that's very easy achieved by, let's say, some formulas. And I was wondering if these formulas in the patent still stand to the mathematics of it.
We are thinking on the same kind of line, because what we do, we log everything in. Every variation is logged in. So one of the guys is to write a program to put all the data in, or we'll look at it. And test by test for a certain condition, it could be.
No, I'm talking in general. Let's say, for example, somewhere around page 70, something 80, on the patent itself, it stands, let's say, this volume of core. The volume of outer core needs to be 17 times bigger. After that, you make the volume, you math actually the volume of the inner core. You do the math for how much hydrogen needs to go in, how much helium needs to go in, how much argon needs to go in.
That, as I said, we need to do an amendment or put a new pattern in for everybody to read. That kind of measurement was done based on use of nuclear material. And that is only applicable when you have nuclear material. When you use the new materials which are non-nuclear, which we are developing, we see a new, what do you call it, a new game, a new standard, a new measurement. What we have seen in one of the last tests is that we have a capability in our reactors to let one of the cores go loose, which means it's not connected to anything. So whatever reaction we see, it's a function of the forces of the core friction or the magnetic field friction of the cores. In the cell core, which is a very small core, we have the capability to let it loose. It stays in its position, but it goes loose on its own. So itself decides its own, what do you call it, behavior. And it's so small that we cannot measure the amount of gas in it, of what sits where. But with a small amount, core, which is a small size, it affects the whole operation of the other two cores. We've seen it, it was very strange to see it at the beginning, but now I've got used to it, I can predict it. So with a new material, measurement goes out of the window. And depends what material this is, what do you call these things are made of. One of the cores has built in about 15 different materials in one wall, 15 new materials. So we see behavior pattern, which is very realistic because we can't have a pure system. What happened is in one of the tests, something went wrong. And we had to open the reactor. There was no choice. When we opened the reactor, the seal which was used for some other reasons we can't even understand how, for whatever happened, we could not remove it. So the engineers decided we're going to cut the seal. We're going to literally machine it. So it's something we didn't know before, what this is going to happen. We took all precautions, everything was done according to the book for no contamination. When you use seals, especially the seal we were using, these rubber seals are compressed between two metals, very, very tight. But the manufacturers, for whatever reason, they have decided to do, where the turn comes to go from one, it's like a clip, they put a plastic in it and they seal it, so the ring stays in the middle, the rubber. They put oil in the seal on the outer edges of the seal inside this metal frame. And without knowing, because we never broke a seal before that way, some of this oil leaked into the reactor, which was unexpected because we did not expect liquid. So we have a contamination. We cannot touch the core because we would damage the rest of the material. So I set up for about a week to understand how I can use this accident or use it to our benefit or learn something from it. We managed to, with the knowledge which it was available, we cannot remove this oil. There is no way we can remove oil. We tried every possible way without damaging the structures which took us months to build. So now we have an enforced condition. We have a oil patch, which is there. We can't do anything with it. So we try to change it into a GANS, try to understand what they use, the structure they use, what oil possibilities could be, what material it is. And we have managed to do it. So we see a different performance from that part of the reactor for the flux. So how do you put this into a book? How do you put this in your scale? Non-nuclear is totally different, and we are going a non-nuclear. If it was nuclear, I know what to do. All we do, we do clean up, shake material out. With this situation, we can't do. So we are running the reactor with a new dimension. What is the measurement can we put in? What size of the core we put in? These are the realities. So what's in the book will not apply, will apply to your reactor, but not to Gert's.
Yeah, I understand. I was just wondering if the proportions are the right one in order easier to start a reactor.
What is in a proportion in the pattern is all to do with a nuclear-based material reactors.
Yeah, so as far as I can see, we all do nuclear material reactors. So.
Yeah, so we don't have...
not without access to the new materials you have.
Yeah,
so we need to deal with the nuclear materials anyway.
But you can't choice material.
Well,
if they didn't allow me to do it, you don't need to get yourself in problem. Yeah, so it's what do you call it? It's a knowledge we're gaining, and we see now even in the cores, we don't need dimensions, we don't need sizes. In a way, that even though it's only 7-8 years old, with the new knowledge of the non-nuclear material, part of it is obsolete, or part applicable to the new knowledge. So we have to write new.
I understand that we're still working the old way, old-fashioned way. I'm trying to get the UV light. Is that gonna work? And I also have X-ray, double X-ray.
I never used such a thing. I don't know. I think Rick is more expert in these kind of things.
Well, I haven't done anything EUV light at this point, but it's definitely on the checklist of ways to try to activate a plasma from either inside or outside of a reactor. The UV doesn't travel well in atmosphere and so on. like
if you
nanometer kind of thing.
If you create a right vacuum condition and material, you create a EUV, you don't need EU. Ultraviolet is no use. You need extreme ultraviolet. Just on the soft X-ray, what is called as a soft X-ray, you get the result. Look at the structure of your own body. You'll find the answer. You understand?
I think so. It's well, I mean, our body is if we had a it is like a vacuum chamber, like you were saying before in one of the other workshops, in that the various elements so on are in liquid, and it can create a liquid or perhaps gas state where the layers in between each layer is essentially a vacuum. In between each different chemical layer is essentially a vacuum. So there's interchanges that are going on between these layers. This is the kind of look at it anyways.
I look at the picture. Is it Anne who's put a picture on? Yes. Your our reactor 3D, what do you call it, 3-core reactor is very much like this, but you can't have the bits hanging in there next to the wall. It's very much.
Do you have something else you want to show with that, Armin, or is?
I actually I ordered the the prototype, but it's not arrived yet. But I have practically bought the vacuums that I can show. This is my.
I like your drawing. It's very nice.
Thank you. I have a lot more actually. This is CAD drawings, and I have this type of actually reactor. Where is it? I can show here. And one question I want to ask Mr. Keshe, if it's going to work with magnetic drive, on a over here to just a rotation part of the motor, it's connected with the magnetic drive.
You can do it, but you have to watch if it affects the plasma or not.
And you have some magnets at the end of the drive part of the magnetic, or the other end of the drive, right? That are magnets in some sphere.
I just these drawings I done it a long time ago actually, and here if you can see rotating, it's I thought
that's the red and blue things rotating there.
I thought before that in construct or this way, that I can put north and south magnets all together like a globe, to rotate it. This was my idea, way before I just made the drawing. I don't know it's right or not,
You got to the bottom end where it comes and connects. You have to, that part. That part.
Here.
On the other side, the other end, exactly the opposite side to this, where it comes in your reactor. You see the piece there. This should not be in, because unless you cascade this in a new materials that stays away from the plasma, you'll find the minute the plasma touches material, you have no plasma.
Actually, but this is all a copper. Only the magnetic drive right up here. If you see, it's here.
I can't see it. Your camera is in the wrong end. Yeah. Okay. Show me where.
Here, right here.
Yeah.
This is all one chamber. There is no holes inside. Here. This part. It's one piece. The sphere is one piece. And the magnetic drive, the motor is up here, and it's turning, and it's, should turn the core.
How do you turn the two cores separately?
It's not two core, it's a one core only. Inside the
you put a magnet ball in the center.
Yes.
withdraw it.
Especially constructed like this half magnets, you know, you can position all together. You know, it's like one globe.
Oh, yeah, I see. I thought you had two cores.
No, you can put the second core, you know.
Does look is lent toward that.
If you shorten this core, the other side, you can put the same thing. You can rotate it together, actually.
But what you got to do is, whatever you do, use this combination or the combination. You have to cascade it. You have to make like a shield for it, that whole thing is covered under one material, the same as your core.
Okay. No, it is one. On magnets, before I thought that, you know, to put the magnets, it will, you know, change something. But I understand right now it's more of a condition that you create, not a material.
When you put a magnet in the center, you condition yourself to a specific magnetic gravitational field strength, because magnet dictates it.
Okay.
So the minute you use any kind of magnetic material, the gravitational magnetic field that material creates dictates the strength of your system.
Oh, okay.
So that's why we moved away from this situation, that the magnetic gravitational field is decided by the whole material within the whole reactor.
But let's say instead of these magnets, if I put the copper.
Doesn't matter. It's got to be the same the material of your core.
Okay.
It has to be. Otherwise, you create. Maybe choosing a different material will give you a different gravitational strength, or it creates the flux. What do you call it? Gradients of it. But what I always done up to now is I choose whatever is in the middle, the same as what is on the outside. Maybe something to try. Maybe you use copper and the other one you use steel, as it's you get a different result. This is what we are looking. And I'm here to learn from you.
One more question, Keshe. About if this core, if you can see it here.
Yeah.
The core is like very short core, and if you have two cores, like turning, let's say you have the same piece, but the other side, and you're turning, you know, the cores actually different directions. Is that making any sense?
We have done this. Then you have no control. I have built a core, and I put 8 screw inside through the bottom. Okay. And I suspended the center core on a 3-axis bearing, giving a permission or allowing the inner core to rotate in any direction it likes and chooses its own speed. And it is a very hard thing to control. You have no control, because the plasma will move in any direction. The plasma will not stay. As we said before, as Gert said the same, temperature in the plasma upper is lower, so the mass is different. When you start rotating it and you start moving it, then you are not in charge of your plasma anymore.
Okay.
And it's a very concept, but I don't think it will work in a certain ways. What we learn, it's a very good concept. I've never seen it before, but I've built a system that's free rotating, and it can move in any direction it likes. And it's very hard to control. It's impossible to control, because you don't know what's the next step, because the reactor decides.
So the core actually, like an electron, spins around in every direction?
Yes, inside the core, yeah. In a way, you bring the electron inside the proton. It's a very, very interesting game. We are doing it now with a 3-core system. I've tested it twice, and it's a very, very interesting result. When you run a multi-core reactors, when you create a vacuum in the center core, like what the idea behind it was when they say the center of the Earth is empty and the center of the sun is full. Yeah. So what we did in some of the tests, we did the center core to the high vacuum, and it's interesting how it affects the flux flow in the outer core. It's very interesting how vacuum plays game in the power of the external core.
Are you saying you had no hydrogen in that central core? It was just pure vacuum?
No, pure vacuum to -14.
Oh, wow.
So
I think you make the same expense time ago.
Well, certainly
emptying the inner core and having something in the outer.
right.
If you
Yeah,
remember.
except I never took it anywhere near to -14. But yeah, that's
very. We have a very good molecular pump, and so it's achieved very easy. What I do, I empty the reserve tank, or allow the reserve tank to go to -14. It takes less than a millisecond to empty the cores for us. So then you see the what do you call it? The change in the flux flow when the magnetic field flow across the core in the vacuum. You see it with a new material. Every time we inject new material, we see a change in the current flow in the what do you call it? In the plasma of the outer core, and we see it on the walls of the reactor, and we see it on the flux immediately.
And where would electrodes be in that case? On the walls of the reactor?
Yes. It's been placed by the engineers on the they made a specific. Just 1 second, please. Just 1 second.
Does anybody else have any videos that they're going to want?
I have pictures that I've put on the forum. I'll send the link there. Okay. If you can see it. In fact, I have 5 more pictures that I've put there. You see the link?
Yeah, I'm just clicking on it.
Yes. So the vacuum plays a very important role in the performance of the magnetic gravitational field of the outer core, and it's direct. And we measure, because the flux, what do you call it, the magnetic flux detector sits about 4 or 5 centimeters away from the core, and we see the change immediately when we create vacuum in the center.
Okay, so another question. My discharge cylinder is about half cubic meter, sort of, and my core is about 10 centimeters, which is about 1.25 square centimeters, if I remember well. Is that enough vacuum into the discharge cylinder to make the core empty?
Usually is, but you have, when you try to have your core, can't rely on the vacuum in the tank. You have to run your pump in the background that is keeping the vacuum at that level. You can't just because your reserve tank is there, just open and let go. You have to run your motor or your vacuum pump into the reserve tank, and all you do, you just open the, what do you call it, for a few minutes. That what comes in gets sucked out straight away. So you can't just create a tank and rely on it. You have to still run a pump for a few minutes that you keep that constant vacuum. You should be
But
enough.
it's
It's
gonna
usually
go enough down vacuum to be able to experiment with it.
depends on your pump. Because what I do, I use a normal pump to -8, and then we shut down and we open the thermomolecular tank, and we go to -14 within seconds.
Well, the new one's supposed to go to -90 or something like that.
Yeah, but we just you do it.
Yeah, I wonder if
But yeah, one of our reactors is a few centimeters. So it's nearly about a 15-liter tank I have. It's a huge amount of vacuum suction.
Yeah, it's similar to mine, something like that. My reactor solar, I keep using the jars, and I have a pretty big discharge cylinder, which is about half meter tall.
You have to remember, when you use vacuum, you create a vacuum. When you use a molecular pumps, molecular condition, you have to let your core run for about 2, 3, 4, 5, 10 minutes on the vacuum pump. That you suck every molecule out of it. You can't just open and say, oh, they're all gone.
Yeah, and imagine that. That's probably is going to be some contamination inside and stuff like that.
Yeah, but every time you do the same,
that's what I'm with my rough pump. We've been doing a lot of tests lately, trying to make sure there's no leaks and so on, and using the new digital gauge. It's quite accurate, and the roughing pump, it could take a half hour to an hour to take it down to 100 micron sort of range, which is equivalent to what is it, 10 to the -2 or 10 to the -3 millibar, something like that. And it takes quite a bit of time, and that just takes it down to the point where the molecular pump can really start to be efficient and work properly. So
have you got the reserve tank?
have we?
Have you put a reserve tank on your pumps?
Yeah, we've got a pressure cooker as a reserve, and that kind of works. But we also use so we've got the chain. You can see on top of our, we've got the turbomolecular pump here, and then on top we got a shut valve in between, and on top is our main vacuum chamber. And we can use that as just as a vacuum chamber and run a hose to an actual tester, or we can use that as the test chamber itself. And there's another hose that goes from the system down to our pressure cooker before it goes into the roughing pump. So we use the pressure cooker as a sort of a reserve tank, and it draws on the outlet of the turbomolecular pump. So once it's drawn down by the roughing pump, that the pressure cooker will act as a draw on the turbomolecular to keep that suction there all the time. Basically, it's supposed to have constant 0.1 millibars. It was 0.1 millibar. Should have a constant 0.1 millibar pressure on the outlet of the turbomolecular pump, is what they claim.
How come your thermomolecular pump is upright?
Why not upright? It's got.
I've seen one.
Well, I guess normally you would clamp this onto a big spare chamber if you were doing some sort of tests on a. It's designed to work on the angle, this particular pump, because it's use oil. It's got grease for the bearings, so it's not dependent on the angle. But it's just this way. I wouldn't want to run it sideways, really. So, what would you have something in mind?
No, I've seen an upright system like this. Maybe I'm old-fashioned.
Yeah.
Well, they recommend this to work upside, so you can run it horizontal, but they recommend in the manual to go up. So
Upright.
yeah.
Absolutely.
Okay. Tabletop.
Yeah, sort of, yeah.
And depending on your pipe connections, I like to actually run our chamber, which is at the top now. I'm going to put that down on the table and run it close to it, I believe. Although it is interesting configuration.
When you run a motor, you have a lot of vibration. Would that stand up in the vibration?
Well, actually, the pump, there's not much vibration on it. You can barely hear it running when it's running.
When you run your core with a motor.
Right, that will be a problem. That's correct. And Guy and I both recognize that as a problem for anything with motor running. So it has to be more secure that way.
Mind me asking that, did you say that you suspended the whole reactor before?
That's what the new reactors are. The new system, the whole thing, you see it in the video. That's why there are some people who said, oh, that the weight difference is due to the bearing friction, which has nothing to do with it because it's hanging off the top. The bearing doesn't matter what they do, the mass of the total system counts.
Right.
So we hang a new, what do you call it, star formation. The new star formation, everything is suspended from the, what do you call it, gets suspended from the same platform. Mm-hmm. So the whole thing is hanging. It weighs about just under 100 kilo.
That's with all the tanks and everything, you mean?
No, just the reactors, just the 7 reactors.
Okay, right.
The 7 reactors with their housing, they do not move in the test.
And the special platform you were speaking of earlier.
Yeah, I designed this platform about 3 years ago. It took time to build it. It's literally like a maze. So you allow reactors to move and you allow them to find their position, but at the same time they can't move away from the plate and they cannot move away from the center or the mother core. It's a strange animal, but it works. And it's got the 5 legs. It sits on 5 legs on the ground. So the whole thing gets suspended. We're going to show this in the near future. People can see the star formation.
Sounds like it's like playing pool with magnetic balls or something, you know.
It's playing pool with the stars. That's what it is, because you create the star formation.
That's a nice one.
Mr. Keshe.
Yeah.
I'm sorry, but I have a vacuum pump. It's approximately 10.6 minus 6 torr, if you can see, and I have a molecular pump. 1 minute.
Where are you? You're in the States?
Yes.
You lot have a strange system on the other side of the water.
Why?
Are you more used to French and the German system, which is tabletop, say like a dog, and it's, you know, you like a pool on the table. These things
are monsters. These are monsters on the table.
Yep.
Carry on.
One question, Mr. Keshe. You know, this pump, it was approximately 27,000 rounds per minute. Is that enough to achieve?
I don't know. Depends on what you want to do, what you're expecting. I don't know what is, because I'm not expert. So you got to understand.
10 to the minus 6 there. Well, my pump's also 27,000 RPM, but it's a wider mouth. I've got this F160 and you got a CF100 or something like that, probably intake, which means that the bigger pump with a larger radius will tend to have a little more capability, that's all. Some of the smaller pumps of the size you're showing there, Armin, turn up to 100,000 RPM.
Just one simple thing, don't forget everything depends of the conditions of your pump. So that's another thing you can need to kind of.
What will be interesting is how you lot gonna create plasma. This is the interesting point for me.
Yeah, this is the challenge that we've talked about amongst ourselves quite a bit. And I know, like Vince, for example, has some interesting concepts and talked about ways of reducing the Coulomb barrier and that sort of thing and creating the actual plasma. But it's still a big sort of unknown factor for us because we don't really know what we're looking for. We don't know what we're...
Let's see what happens. What I see with all your works, with the designs. I was discussing this before with people near to us. We have to release certain amount of information in next couple of months or next few months that you can go to the next level, because I see nobody's achieved that, or people are trying things.
Well,
and,
for example, one thing that we run into is we spent literally months trying to get rid of leaks and just create a basic vacuum, even with our roughing pump, let alone the turbomolecular pump. And it's only been recently that we're getting a grasp on that, how difficult it really is and how elusive that is.
Yeah, the first thing is for people who are going to start a new one, because I received the email from the guys in Malta, and they've gone into that section, because when I was in Malta, I explained to them where the problem. Well, a lot of your vacuum condition problem comes from these screws you put in on the flanges. That's your biggest problem. Second biggest problem is at the point of none of you run a multi-core system. Where we run a multi-core system has totally different problems on top of what you have. So you got to remember, or you got to put it in your program, that if you run rotating systems or you're running a rotating valves, as I said at the beginning, look at not only vacuum, make your system when the gas goes in as well, because it's a different proposition. And the other thing is, if you are again using one gas and two gas or three gases, then the game changes totally. If you go to nitrogen as a core, nitrogen will find the smallest hole to escape. I usually use nitrogen only for leakage test, not for running the core, because nitrogen is the best leakage test. If you put nitrogen in your system and you see no leakage, you can work for months without it. You don't need to touch your core. And one thing which is very interesting, before we used to open the core 2, 3, 10 times a day to change things. Once you have a sealed core, try to find a way not to touch it, because to seal it again is God's job. I've been there. We worked 10 days to make some seal for half an hour test. Now we gone the other way. We do 10 hours of test for 1 hour of repair, if we need be. We still get problems. The sealing comes through if anybody starts a new system, do not, for goodness, make any system with flanges and screws on, as I see a lot are doing. Look at the system which is made by the Maltese group. They are doing the threaded system instead of a screw system. I think Bulgaria, Polish guy is going the same way with the screw, micro thread.
You're talking half the spear would have female threads and the other half of the spear would have like a male thread when they thread together.
90% of your leakage problem goes through the when it's finished. 90% of your leakage problem is solved. And you just put, where the two at the bottom, where two interfaces come together, with the last turns, literally, you put an O-ring on that, and you put a silicone on that O-ring, on the O-ring itself, or you put a silicon and you embed the O-ring in it, you have 100% seal for all your tests. But the problem with it is, if you want to open the core, that's got a problem. And the only way you can open the core, which has been locked like this, is you put your core on a slow motion, very slow, something like 50, 100 revs per minute. You get, you know, these gas torches, hand gas torches they used to make burning on the, what do you call it, off the woods or whatever when you're painting. You keep it about 3 or 4 centimeters away from the core, and you let the core to rotate for about 2 or 3 minutes. And then in one move, you open the core. Otherwise, you can spend hours trying to open the core. And the other point you have to remember when you make a micro threads is you allow for a tool that you can lock your system to it, that you can turn it. Because once you turn and you have nowhere to grip, you lost it. So on the back of the thread externally, you make a place for a tool that you can tool and to push the two hemispheres in an anti-clockwise from each other, and you open it up. And within 1 minute, your core is open. Within 1 minute, you can close 100% seal. No vacuum loss. These screws are the cause of a lot of problem because you can't get the surfaces 100%, and when you open, you get a small scratch and you get a leakage. So if you go for a micro thread, male, female, and an O-ring at the bottom with the silicon, you can use any silicon then because nothing goes into the core. Because when the male comes down on the female, it's at the bottom part, it pushes the silicon outward, nothing goes inward, so there is no chance of contamination. And with the micro thread, you have about 10 threads instead of 1 or 2 or 3 in a normal thread. So there is no way silicon go back in thread. You find 100% seal. You solve all your problems in one go.
So, Keshe, sorry.
Yeah, that's okay.
Well, I've started to work on the ceramic reactor. I've put a few pictures on the forum. I use flanges, but then I should go to another kind of join of the two hemispheres.
Go down and go on the Keshe Foundation video of the weight reduction and look closely at the reactor.
Yes, well, I do understand what you meant. Yes, I do understand.
We have a tool which is like a hexagonal inside, and we just put 2 of them, one base, one top, and we just turn it and the core opens up. No leakage, 100% seal every single time. You have to move away from the bolts and what do you call it, the screw job. I have 4 reactors which work on the bolts and the screw, and I always have problems. I don't know how you solve it, but it takes us ages to get it.
Yes. Well, the thing was that I started to use ceramic and making the pieces screw like you offer there seems to be in ceramic. It will be a very big problem to have a thread to screw the two pieces together.
Yeah, but if you do that, you have to put an O-ring groove on both sides of your ceramic inside towards the inside the core, not beyond before the threads, and then you got to make it precision groove on both sides, and then you put an O-ring in the groove and you seal it again. You get the same result. I think is one of the groups tried to put a copper inside the groove to make a copper seal instead of an O-ring seal, and they had problems with it. So The best option is micro thread, female, male, and you don't need even to think about vacuum. You just carry on with your tests.
Mr. Keshe, what about the welding? Why we need to open the reactor so often? Let's say if you build a reactor and you want to run it, you're just welding it, and you just gonna have better vacuum, I think.
I have 3 of those we welded.
Mm-hmm.
This is a very difficult system to run, because then you have to work with probes and you have to keep the probes. We built this about 5 or 6 years ago. You see it on one of the original pictures of the Keshe Foundation. We've done that, and that was a time when we were not using nuclear material, and we found a lot of problems with it. Huge amount of problems, because you need to get in your reactor to test different conditions. In the future, when you mass produce, you can make that kind of thing. But as a prototype testing and you test different conditions, environments and materials, you need to get in your reactor. You need to be able to put things. You need to be able to see what happens, what materials you generate and you create. You will find out once you start going into production of energy and getting a system which responds to your magnetic gravitational field production, you will find materials which you create. You'll find you become God. You dictate what you can produce, how you want to produce. Then you want to get in the reactor to see where the things are.
Oh, as far as this is a pork chop, I'm okay with it.
No,
Another
make a pork chop, but you can make protein.
Yeah, well, it's better to barbecue. Another question. I have a dental X-ray. Is that gonna way overshoot the activation?
What?
I have a dental X-ray, which is pretty close to extreme UV. It's just on the X-ray side. It's not really hard rays, but is that gonna do the job?
How are you gonna get? You have a beam. You don't need a beam. You need the environment of radiation.
Could a beam not activate the plasma?
I never thought of it. I don't know.
What
I was thinking about when I release the helium to X-ray the tube where the helium goes to activate it. Or I can just shoot in the core. That's another thing.
I don't know. X-rays are pretty tricky things to play with, and I don't want to be near any of it. So you have to make sure the wall, the thickness of the wall, and the material of the wall does not allow anything to come out. This playing with X-rays is not a joke, especially X-ray machines. I've been born in it. I know the game. I know exactly what the pitfalls are. So I never ever considered X-ray machines and X-ray systems. I prefer to work with alpha, beta radiation than X-ray machines.
Mr. Keshe, the last video you showed, you mentioned that only hydrogen you are using in the core.
Yeah.
Only one gas?
At the moment, we only use hydrogen.
No, the last system that you showed, you mentioned that it's only one gas.
Yes, it's only hydrogen.
It's only hydrogen.
We have on a standby helium and nitrogen, but these are for conditions which we might looking for.
So rotation of hydrogen, it creates ultraviolet light?
Pardon?
Rotation of hydrogen, it creates ultraviolet light, extreme?
No. Not to my knowledge, unless you don't have the not to my knowledge, because I use hydrogen, but I use new materials which I've developed.
Oh, okay, that's different story. Okay,
it's
no.
a totally different thing. It's a different. I've seen somebody has put something on a forum somewhere that the hydrogen in a vacuum creates this and that. I haven't seen it. Maybe it does. Maybe somewhere in the literatures you can find it. Then you have to find out how it does it. But I always, and I keep on repeating, I always look to create conditions, not create or make things for a specific job. Because when you create condition, you dictate the situation. When you have like X-rays, you are limited to what that system can give you. But when you create environment, then the environment tells you the possibilities and the things which you don't know. The only time we use a specific, material, that is in using nuclear sources, and we use huge amount of it. How you can do it with one ray, I don't know. But we, within a core of 20 centimeter, with its operations, we use up to about 400 sources. Because you need a homogeneous plasma, continuous production, continuous holding to the plasma too. You can, one ray, I don't know how it can be done. You have to create a condition.
There are lasers that are used now to create conditions in a plasma and create plasmas. Maybe that would be another process that could be looked at.
Another process, yeah. There are different ways of, what do you call it? As they say, the skinning the cat. But I know my way, right. And the ways which is continuous. But what I've done, I've more or less repeated what we see in the universe. So in universe, we don't find laser beams. We find environment of fields.
I really like your quote, we replicate the same technology as the universe. And I have that up on my wall here, blown up as a saying. I like that one.
No, because you look, the same process in the boundary of this itself in the boundary of your amino acid. What better example you want? If it's repeated and you see the same performance in the galaxies, what else? We followed the bird, we copied the way the bird fly. Now copy what the universe does, but understand how it does it. Then it's easy. And that's all you need to do. This is creating condition, creating environment to achieve what you're looking for to do. So if you look in the structure of the Earth atmosphere, some people never understood why we have nitrogen on the upper layer. Why? How come the heaviest gas in the, what do you call it, the structure of the hydrogen and the rest is on the upper layer? Because it's created in the upper layer. It doesn't go from the bottom up, it goes from the top to bottom. You get the rain. The rain is not just the rain. Rain is to bring down the nitrogen which is created in the upper layer. People don't understand the whole concept of creation and life. In the new book called the structure of the solar system, I explain this in detail. So you try to replicate the same. And then you understand why we have all the factors we have, why you have nitrogen in your amino acid. Understand the process of why the hydrogen, the oxygen, the carbon, and the nitrogen is the basis of life on this planet. I've explained that in the new book. Then you replicate it in your reactor. Then And you don't need to look for a laser beam. You don't need to look for, what do you call it, different radioactive materials. As I always say, I thank the Belgian government and all the things they did to stop the foundation in putting us in the direction of where we are and doing things in a universal way. They brought us forward maybe about 10, 20 years, but it's to the benefit of mankind. You look what is happening in the micro, and then take one to another. You don't understand it, work with the other one. Why do you have nitrogen in the upper layers of the atmosphere? Why? What's the reason? Where does it come from? It's the heavier gas. It should be at the bottom on top of us, not on top of the planet. There is a reason, because it's created on the upper atmosphere. And in creating, it allows the same process as happens in your lung, in observing, or what do you call it, in releasing the energy from hydrogen. So you just need to create, your lung continuously creates a condition of a plasma. In your breathing, you continuously create plasma in your lungs. But we never been told. We always told we breathe oxygen and we breathe out oxygen. In the new paper which is coming out, and I gave a talk about it in brief in Bulgaria lectures, if the people here have the videos to release it, I explain why nitrogen in the lung and how you release energy in your lung. You do the same process in your reactor. You don't need the X-ray. You don't need the nuclear material. You just copy your lung, you still come to the same process we are doing. And the lung is static in a way compared to, or go a step further, look at the operation of the limbs in your body. This is the same. The limbs and some of the, what we call glands in the body, do the same job. Exactly what nitrogen does in the upper atmosphere in a different way.
So in the lung, Mr. Keshe, in the lung, oxygen separates to nitrogen and to atoms of hydrogen. And what caused that separation?
No,
is that...
no, it doesn't. It doesn't. It doesn't.
No?
It doesn't. No. In the way I explained it in the book which is coming out, the function of the amino acids, what the amino acids are doing. In the lung is totally different process. In the lung, the oxygen through presence of nitrogen releases helium to hydrogen, and the oxygen becomes carbon, and a carbon links to free oxygens or the oxygen molecules which are in the lung, and it comes out as CO2. The rotation of the creation of the CO2 is done within the lung. I'm writing the paper. It's going to be released. What they say, oxygen crosses the wall of the lung. I don't agree with. Scientifically, I explain how. So the presence of nitrogen because it's 6% of what you breathe in is nitrogen. Nitrogen doesn't go in and come out nitrogen. Nitrogen goes within your lungs, again releases extreme ultraviolet. In that position, plays two games with forces the oxygen and ionizes the hydrogen to release energy equal to helium. So the energy crosses the wall into the blood, and the CO2, which is the carbon which is created from the release of the helium from oxygen, joins or links to two oxygen molecules, and it comes out as CO2. This is totally opposite to what we've been taught in the whole of medicine. They put me in prison as a lunatic, but scientifically we can show this. The same thing is you see it. This is a hypocrisy which sits in the world of biology, nothing to do with medicine. Look at what we say when you release energy. You see bright light in the sky. When you have blood going into your lungs, when it comes out, When the blood comes into the lung, it comes as darker color, and it goes out and it becomes brighter, and they call it the oxygenated. There is nothing, there is no truth into this, because what happens is literally the energy of the hydrogen, or the equivalent to a helium, is released across the wall of the lung into the wall of the blood. So the blood receives new energy. So what does it happen? It becomes much more active, it's brighter, it's got more energy. And this is exactly like when you have a switch in the house, a controller, the tuner. As you turn the current higher, the light becomes brighter. As you, what they call a dimmer switch, as you turn it up, you reduce the energy, it becomes darker or dimmer. So the same thing happens when your body. Oxygen energy of the helium, which comes from the ionization through the first nitrogen and the helium, and then the helium plays the same effect to create secondary ionization, releases energy which goes across the wall and energizes the cells which carry or are of the oxygen levels of the amino acid which go through. So does any oxygen crosses the wall of the lung? I don't think so, because I always explain, and they have made system to show actually oxygen goes across, because they build this system to confirm their way of thinking. They think it must be correct. But my question is very simple. A molecule of oxygen is huge. An atom of oxygen is huge compared to atom of a hydrogen and a carbon and a nitrogen. If oxygen crosses the wall of the lung and the vein to go into the blood system, what about the thinner one? What happens to the oxygen, hydrogen? Hydrogen should be flowing into the blood cell like nothing, because comparison to the size, comparison to the charge. So does actually any oxygen, which we've been taught from the beginning, crosses the lung into the blood? I don't think so. Scientifically, it doesn't make sense. As a physicist, it makes no sense, but they say there is a change in the pressure, blah, blah, all sorts of things which allows the oxygen to come and cross to go to other one. It doesn't make sense. Scientifically, when you have a nitrogen is an ionizer, allows through the fine tubes of the lung, creates a vacuum condition of the space. And in that vacuum condition, instantaneously releases by ionization, by the pressure, helium. You got left with through the extraction or the expansion of the lung, links up with the oxygen which is coming, it comes out as CO2. I've asked scientists in universities to start measuring the number of the carbons come out with the number of oxygen which you breathe in, and then allow the double O2 to, you will find out the number of carbons are exactly to the conversion rate of the oxygen to carbon in the lung using nitrogen. Nitrogen does exactly the same process in the lung. That's why you have a huge amount of proportion of nitrogen in the air. 65% to 16% of oxygen. And this is because the release through vacuum condition of lung allows a huge amount of energy and extreme ultraviolet to ionize the oxygen into helium, helium into the energy levels of the oxygen release of hydrogen. And then you understand that CO2, how it works. And then you find out the whole biology books has to be written, and they're not ready for it, because it's the same as when we said gravity, how it's created. When we open the Pandora box of the medical, which the books are getting written, I'm writing it as we go along, you'll find out the biology needs to be looked at different way. And then when we start applying the same know-how in medical science, you see strange things, and they say he's a crook, he does this, he blah, blah. No, because we understand the basis of creation, which is the interaction of materials. That's all it is. Very soon you will see documentary coming out from the foundation on the basis of the medical. It's one of the marvels of the foundation. I am proud to see this thing come out in the next 2-3 months. It's a paper following with a video of one of the conditions which is uncurable in the world of medicine. Governments are looking at it. World health authorities are looking at it in the background. What is the outcome of this thing? And all it is, there is no miracle. It's understanding the operation of hydrogen, the operation of nitrogen, on the condition of gravitational magnetic field of the Earth. That's why it led to the creation. Now we understand the process. Repeat the same thing in your reactor cores. You don't need radioactive material. I wasted 2-3 years battling with the Belgian authorities to hold on to my nuclear materials, but at the same time I try to understand the world, the way the planet works. And this planet works the same. Look to create a condition. A condition billions of years was created, which allowed nitrogen, hydrogen, carbon, and oxygen to come together and convert into a matter which we call it amino acid. How did it happen? And then how did it come to start moving? Then you look at the conditions which was created for a movement of a cell. Very simple. And then you see how creation is. Then you can create human body anywhere in the universe. Then you can do what we do, like a growth of a toe or allowing lungs to repair. There is no miracle. There is no crookedness. There is no, what do you call it? Harji-barji. Understanding the process, repeat it in your reactors, you create a condition and you achieve it.
So if we create the right condition of vacuum in the reactor and we have nitrogen in the reactor, we can release UV, or do we need also other materials?
Yes. You don't release UV. You release extreme ultraviolet. UV does not work. Extreme ultraviolet, which is known as soft X-ray. Yeah, that's what you need. The energy.
So just control of vacuum, or do we have to control also other materials? So let's say
we used to use the nuclear material to create that condition. Now we developed a material which does the same situation. If you look at it, we created a material which is like the upper atmosphere of the Earth. So we don't even need the nitrogen. Or due to hydrogen going through the process, plasma ionization is done and the plasma is opened up. You don't need, if you need nitrogen, to me, to my understanding, maybe 100% wrong. We use the nitrogen when we used to use nuclear material. And as I said before, now we only use hydrogen because we achieve plasma condition through the same process as the new materials. These materials are unknown. We don't even understand a lot of it. Because I see different materials created intentionally and unintentionally, and they are like powder. They are very much powder, and then we allow it to be, what do you call it, to be vacuum fused or to be laser fused to the body of the core.
Sintered, I think, is the word for it. Is that the word you're looking for, sinter?
No.
Okay, that's how they make...
let me explain. The language I understand, maybe you understand, I can explain it. We create a magnetic gravitational environment that these materials link together themselves. We don't fuse it. I call it just like a laser fusing, but you can't do millions, billions of pieces together. But in a way, the way the material came to create Earth in the center, we create the reverse. We do it on the outer. You understand? So it's like a sponge. When you touch it, it's very much a spike. But we create a very specific condition to allow to get to this sponge, and it's not it's not that you see it microscopically. As you see it, you physically see layers and layers of this, what I call powder. And then when we test, when I put it through the turbomolecular, There is no material flow, which means they hold to their position. Because if it's a dust, it gets sucked out when you go at such a high vacuum, and this doesn't happen. So the system holds on, the material holds on to the walls through different what I call gravitational magnetic strength of the material itself. It's a very strange thing. We have to study what the material is. I don't touch it because I know they are mainly like a cosmic dust. They have certain dangers involved with it. And I usually use 2 or 3 gloves, plastic gloves, before I touch the system. That in case I come in touch with it, there is a barrier. And people who've been around me, they see I use rubber gloves like, what do you call it, tissue paper. You can't just open a core and close a core with hand and think you're going to do it. If you see a fingerprint of you on a glass you just passed, then imagine how much fingerprint is in your core. You have to clean, totally, absolutely clean before you close your core. Because that fat, this is amino acid, the fingerprint is a fat, becomes part of the supply to the system. So you can imagine how much you're putting in there. These are little things we learn over time, so it's something for you to work on and learn.
Yes, you have a lot to work on and learn. This is true.
That said, we're trying to open the lab to what do you call it, to everyone or people. It's not going to become a museum. It's not going to become a, what do you call it, a roadshow. People who are working like you lot, and you're spending your time and energy in trying to help humanity and yourselves and your race. We do the same with you. I think it's a time to open the door for you lot. We open the door with the Iranians, we open the door with the Italians now, and I think it's time to open the door for the rest to come in. But it won't be a, what do you call it, it won't be a fanfare.
Free for all.
No, it is free for all, but it won't be a fanfare. You come and have a look and go.
Yeah.
You come to bring your knowledge, you come to teach us, and we learn from you the same, and we teach you what we know. This is the flow. And we open the doors very soon. We deliberately place that video on the internet. We don't care what the monkeys say on the net. They are just there to us to confirm their own existence, their meager existence. But we put videos on for the others to understand how it works, and they can copy it. Because I know a lot of you, when you saw the reactor in April, you start making copies of it. You studied, you analyzed it, you looked at it your ways. The showing of the reactor in April was a major breakthrough in allowing a lot of people around the world to see how simple it is. I can do it. And that was the whole purpose. And now the people who made that effort, like a lot of you, a lot of people on the net, and even the scientists in universities and other institutes, are welcome to work with us. The door is opened up. Just give us a few more weeks, few more days. When we are fully ready, then you come in. You are part of the foundation, you're part of the structure of the humanity. So we teach you, you teach the others. The process has started. What we said we start teaching, we have started allowing outsiders to come in. I shared my knowledge with the Iranian authorities 5 years ago. Now I share my knowledge. When I go, the people who work with me, around me, they know. It's not that you do this, you do that. Every step is explained. Why? The reason. Every analysis of data is explained. Their opinion, we feed from each other's knowledge. It's not that I'm there, I've done it. They will tell you, the people who work with us now, the team which are around, every step, the reason I do it, the reason I see it is there. A lot of time we have a guy with us that I stand back, I said, I see you explain, and he is methodical, he's amazing. He goes around and he says, okay, this is and there. When he cannot find an answer, then we start looking at the thing, because, okay, we see a weight suddenly drops. We don't say, oh, wow, the system dropped weight. We stand back, he goes around, he looks, no system has fallen, there is no explanation for it electrically, scientifically, mechanically. Then we as a team, we decide, okay, now we have to explain the situation. Now we open the door to all of you. You're all welcome. We are in the process of arranging even people who can't afford but they have the knowledge to come to the foundation, to stay with us. We have set the structure up for this purpose now. Just give us time, then you come and learn, and you teach us as much as we can teach you. Just need a few more weeks and time.
That's great, Mr. Keshe. Thank you much for that invitation. That's outstanding.
You stand ahead of you.
Mr. Keshe, is it the goal to work with our own system in your lab and learn about it, or
no problem. You can bring your system and we teach you how we see to work with your system, or you come and learn. You can work both ways.
Because the concepts are all different from all our reactors. They are all different concepts, huh?
Yeah. You bring your concept. There are millions of stars in the solar system, in the galaxy and in the universe, and everyone works in different way. Your system works as good as me once you know how it works, huh?
There's many flavors in the ice cream store, right?
Oh, but that's only about 20, 30. The other one is billions.
Yeah.
Do we have to go through Desiree or something to arrange something in the future?
We will set up, we don't announce it, we will set up, we'll invite, because don't forget, I have a huge file of nationalities and scientists in different countries who are working and developing. You don't see all of them. They don't want to be known. We respect their position. Yeah? When we open our doors, I assure you, we invite scientists from NASA. We have direct access into the NASA people. They are quite welcome. We have access to the Iranian nuclear, space people. We have access to the Russians, and we have to the Chinese and Japanese. They come the same time as you. Okay. It won't be nationality, it'll be people who can make the difference, but at the same time, governments and people at the same time. Okay. Our doors are open to everyone, but first of all, we had to go through a non-nuclear. Now it is a non-nuclear. There is no threat to nobody. This is the beauty with non-nuclear. There is no more threat. There is no more, this guy uses nuclear material to do with this government, with that government. We are working non-nuclear. We are all working on the same basis. It's just going to a conference, learning how the other scientists do their things, their way. And we open our doors. We have opened our doors. Not as something we're going to do. I kept the situation very sealed for what I disclosed. I tested with my beloved Iranian. And now we opened it to the Italians. Why not the rest of the world? But let us do. I have a very good Italian team which is working with us. We have a very good Iranian team which is advising us in different ways, and we have people in 2 other countries who are advising us and helping us. Let us do the job. When the table is ready, we invite you on the table to eat together.
Okay, thank you very much.
You're welcome. Any other question?
Well, we are waiting a lot to go further in that non-nuclear way. And well, for the moment, we just go further in what we can do.
Just to start looking at how conditions are created in your own environment. The reality, it is not the way it's written in the book that you have accepted. It's a big difference.
That's go ahead, sorry.
Then you see you can achieve what we achieve within a matter of days.
Yes, it's a way of seeing things, and it's not always easy to see things in another way that we have the habit of seeing things.
That's a lack of knowledge, I think, what we have, you know.
No, it's not lack of knowledge. We have it. It's part of us. We decided to deny it. because it would stop ourselves to find out how ignorant we are about our own environment. We chose the easy path. We followed what we call follow the leader. And the leaders did things to suit themselves and to make the name for themselves. As you know, we were invited, it's on the internet, you can go and have a look. I was invited to make the presentation of the CO2 paper and how CO2 is captured. A conference in Belgium on the 30th and 31st of October, International Conference of CO2. And they our name, and then the governments put pressure. I'm the only one who's been taken off the list. Why? If it is a CO2, we can show how CO2 is it can be changed into a matter, how it can be used, agriculture, industry. We should be the only organization we should be in that conference, at least to show what it is discovered. Why the Keshe Foundation is the only organization which is taken off? Because of the pressure by governments. They don't want people to know what is to come. Just go and I can put a link on the internet. You can go and have a look. Keshe Foundation is the only one which has been taken up, and they announced it that we're going to be. But the governments put so much pressure on the organizers, they said, sorry, we cannot accept you. We have to take your name off. So,
censorship or something.
This is what is there. It's go and look. It's the CO2 conference 31st of October 2013. And if you go on the Internet Archives, you see empty cash from Keshe Foundation, CO2 paper. Government put so much pressure on the organizers. They wrote back to us, I'm going to release all the emails from them. Then you can see what we are standing. We don't talk about it, but the pressures are huge for the public not to understand what has been developed. But you people are doing it now. The cat is out of the bag. So later, I see a couple of organizations are there. The governments who have a nuclear capability are already there.
But it's not better for them, just to develop it. It's going to be better for everybody.
They have developed it. What do you mean they're going to do it? They have developed it. When we gave the key to the American government last year, I can show you emails direct. The key to directly Washington, NASA quarters. And we have an email confirmed it's arrived at NASA the day it arrived. NASA boys are working on it. They worked on it straight away. This was a key missing. It's the same with when you give the keys in technology like this, the government don't sit and just watch, they act. So that's what I said just a few minutes ago. NASA boys, you're welcome. Come and have a look at the nuclear system. You work with the nuclear. Now we developed a stage further. So there is no hazard. This is very good because if your reactor in the space blows up or something goes wrong, nobody gets contaminated. This is much better than the nuclear that everybody could get contaminated. And the thing is, when you open the reactor, there is no nuclear radiation, there is contamination. In a way, in blocking us, it helped us develop the next step. We're keeping very, very quiet. I think you've noticed. We reduced the size of the website. We reduced the size of the activities, what we announce on the website. We have reduced the medical side to bare bone minimum because they were attacking the foundation through every link possible. We brought it down to the skeleton we can control. And you see what the position we are in now. Because why, I always say if I would have carried the American passport or a British passport, I would have been Einstein II, or Einstein beyond Einstein. As is in the Middle Eastern and Arab nations, they call me Tesla of physics, but you cannot see it on this side.
You are for us.
No, but it's the reality because the only problem is the color of my passport and the present situation with the Iranian government. Otherwise, my knowledge would have been free. You all would have access to it. The world would have enjoyed it all together. The time will come. There is somebody on this forum, there is somebody on the internet who knows our position in respect to the American government because they've been on the receipts of the information and how it's been justified to killing, and to me is meaningless. And I'm sure His Excellency President Obama listens to all communications and all these presentations and even this lecture, this, what do you call it, workshop. They go through it word word. And we know that because we received the response in writing. And my message to His Excellency President Obama is very simple. Let's talk peace, then we don't need to kill. I think the message of the American government's got the message. We are here for peaceful, and we share the knowledge free with everybody else. People sent us threat. We're going to the health authorities of this government. We're going to put you to prison. We have a license. We've been given a. We are working within the permits we have. They can go to any government. We're going to bring you down. Your place is in prison because you're doing illegal business. I have a company been authorized to search medical. And we have a permit. We've been given and we've been insured. So you can talk whatever you like. The people and the government know what we are doing. Anything else?
I think that's probably good for now. We've been going about 4 hours here, I think.
I think, Nick, it'll be nice if we have the next session with the guys from Malta.
Okay. Hmm?
We can, because I've seen them, they built a very nice reactor. I've seen it yesterday. They sent me the link. If you can ask them when we go for them, because by then we might have a news for you as well further on with development.
And would that be in another month then, or approximately?
Every month, yes. Do it for end of October. It'll be nice.
Sure, that works good. I'll be in contact.
Thank you for your time, and thanks for everything else.
Thank you, Mr.
Thank you much.
Thank you very much also.
Thank you very much for everything.
Thank you.
Bye.
Bye.
Wow. That was great.
A lot of information.
Yeah.
Okay, let me just.
Rick, did you receive the pictures from me? The cat rows, the pictures